education, minds wide, knowledge flowing, equations on the board, numbers never sleep. Teaching math and physics while them haters count sheep. Actual education, tune in and get schooled. Flipping textbooks, breaking all the rules. From Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What is up, everyone? Yeah, we gotta thank Sensation for that intro, dude. Yeah, Sensation made that. Good job, Sensation. Yeah, I figured, you know, we were talking about it. It was gonna be a good idea to have. One second, let me make sure I'm sharing my screen. To have some sort of, I guess, a little waiting screen while things load in. So yeah, no, it's very cool. What is this intro, right? Yeah. It's apparently made with AI. Maybe Sensation can explain to us how they made that. What's up, Sensation?
Oh no.
Oh no.
Oh no.
Did you see it on Twitch? Did you see the intro?
I did.
Yeah, that's pretty cool, dude. I like that rap, dude. That rap is sick, man. And
what to do.
yeah, honestly, yeah. Well, I'm curious what your prompt was, because honestly, the beat is pretty sick too. I was a big fan of the beat. The beat was pretty cool.
I don't tell you.
Is it using Suno?
It is, because I asked Penn for some help, and he was just like, just use Suno. I'm like,
Oh yeah, just use Suno. Yeah. Yeah, Suno. I think we've used it before. At least it's not like those terrible intros in 2017. Agreed. Yeah, those ones suck. Yeah, AI did all of that. Sensation put in the prompts. You have to put in the right like questions for it to come up with the right stuff. But the music, the lyrics, all that was created by AI. The video I kind of edited. That's I have a bunch of like gold visualizer stuff from when I do raves, so I just like put it as a backdrop. But yeah, that song is sick. Sick. Cool. All right. What is that, Ace Dog? What is that with the fingers, bro? What is this? What? Excuse me? What? I'm confused by that. That reminds me of the Arthur Fist meme. Anyone know the Arthur Fist meme? Yeah, let's see. This one. This is the one I'm thinking about. When Arthur's about to like choose violence or something. Anyways, it's election day. Super interesting. I know some of you students are not old enough to vote, so I guess I know you're kind of like, well, how does this affect me? Well, it will in the future, unfortunately. Anyways, yeah, so we're gonna do some math and science questions to help you guys out. But if you want to just see all the fun election stuff going on, Penn Center, one of our streamer friends, is doing I think he's doing like a marathon stream today, probably like 8 or 9 hours. Let's see, I think he has her somewhere. Twitch, and I think he's at Penn Center. Let's see if he's live yet. Let's see what he's up to. I'm just curious. Oh, he's not on yet. Oh, Penn Center. I thought he was on the calendar. Yeah, if you ever want to figure out when all our friends are streaming, Just put exclamation cal. And that should come up with the calendar. So let's see. I thought Penn Center was on today. Yes. Super special American election stream. All right, he's probably just a couple minutes late. That's okay. But yeah, we'll be either rating him or Zach after this. So be sure to drop by. We'll be partying in his stream to celebrate the beginning or end of democracy. I don't know which one.
Oh, no.
Anyways. Okay, cool. All right, we got a lot of questions today, so let's run through them and start off the stream. Welcome everyone, office hours, memes, doc schools, actual education, the stream helps you with math homework, science homework.
Nice.
All sorts of fun stuff. Sensation Black, 5 stream streak. That's sick. Nice, dude.
That's dope.
Okay, let's see. We got some questions to go through today. Addy, I think you're up first. Let's see. Number 11 and number 12. That's what he needs help with. Let's see. Ooh, this looks like some geometry. Oh, no.
I need to erase this.
At least it's triangles and not circles. I really don't like circles. I'm not a fan of circles. I need the smooth brain for this.
What's a SpongeBob?
Okay, cool. All right. So let's try to go through this one, Addy. It says, find x and the length of each side if triangle ABC is an isosceles triangle with AB equals BC. Oh, that's pretty fun, actually. This is actually a pretty challenging question, Addy. So yeah, isosceles is the key word here. Isosceles means that two sides of the triangle are the same. Ace has been here every single... Oh, wow, dude, congrats, dude. I think the most we've seen is 100. I think Ethan had a streak for 100 streams at one point. Yeah, it was insane. But you're moving your way up there. Okay, so they're saying this side is equal to this side. Okay, so this side is equal to this side. Okay. And they want to find the length of each side. Equity had one as well. Yeah, Equity had a super big streak as well. You're right. You're right, Ace. He did. Okay. How do we do this one, Addy? I got two sides of a triangle. Oh, look, this thread again. Team Rocket. I appreciate all the memes. Pigeons, fuck the streets. Dude, what about justice for Peanut, the poor squirrel, dude? Has this made its way into your news cycle yet, Sensation? About them like euthanizing this dude's pet squirrel?
Yeah. Peanut, yeah.
Peanut, yeah.
That was the end of democracy.
That was the end of democracy, right? Although, to be fair, like, apparently he had like he's had the animal for like 7 years and never registered it as a pet, and it's a fucking rodent. So, like, I know it's cute and everything, but it's a fucking squirrel. Like, certain states have rules about like what you're allowed to have as pets. And things that carry diseases are usually not a good idea. Also, wasn't he running like an OnlyFans? There's some interesting stuff here. We'll read into it later, but yeah, it's it's a little weird. Okay. So we do 4x minus 3 equals 2x plus 5. Yes, we do. Yeah. So we know this side is equal to this side, so we can set them equal to each other. Cool. So 4x minus 3 is equal to 2x plus 5. Cool. That's not too hard. Yeah. All right. What do we do next then? This is pretty easy for you, Addy. I'm going to give you something harder. I know you're smarter than this. Solve it so we get X. Yeah. It's all right. You don't have to pretend to be stupid. It's okay. I know you know how to get the answer. Yes. You subtract 2x. You add 3. So you get that. Yeah. 2x is equal to 8. X is equal to 4. And yeah, cool. Easy. You just plug it in, right? Okay, cool. So then this is 13. This is 13, and then this is 6. Yeah, nice. Okay, cool. That makes sense. All right. But let's give you an actual question. I appreciate you submitting something, but I know you already know how to do this. Let's see. And I always tell students like the point of this is for you to learn things that you don't know. What is this? You have to go back. What? What's with that? I don't get that.
It's the Reddit logo.
Oh, I know it's the Reddit logo, dude. Yeah, but what does it mean, dude? How's it go? How does it work? Whenever
someone talks shit, you just like, no, back to Tumblr. Reddit,
oh, back to Reddit. Yeah. We say that on 4chan a lot. We say, go back to Reddit. Yeah. Yeah, no, I get it. I'm not gonna do that. Dude, there was that one question that someone submitted that was absolutely insane. Remember, there was like an 8-minute YouTube solution for it. I was like, I do not want to do that. No. Let me look through the other questions people have submitted. I think there's usually like a good triangle question in here somewhere. Someone's done. Ooh. Yeah, I like this one. Uh-huh. Yeah, let's do this one. I think it's a good one. Addie, we're gonna make you use your brain this time. What grade do people do algebra 2 and pre-calc? I mean, it depends. I have kids doing algebra 2 in 10th and 11th grade. I did algebra 2 in, I want to say 9th grade. What's this one? Kermit? God damn it, Sensation. Sensation, did you see the one about like the sunscreen that they were locking up? That's a funny one. Thanks, Critical.
Wait, why were they locking up sunscreen?
Well, okay, so we'll go into this, but there's a big, like, petty theft is a big problem in the U.S., so they started hiding all the expensive things that people were stealing, like, behind locked doors in grocery stores. So, for instance, if you want to go buy deodorant, you have to go to the front and ask for someone to give you a key to then get the deodorant and then bring it to the front and you pay for it. I don't know if they have that in the U.K. We have it here in the U.S.
Perfumes.
Yeah, okay, like yeah, they do it for just fucking basic health and hygiene at this point because people are just
But
stealing
like links or axe
Yeah.
or whatever you want to call it. That's like a pound for a thing. So just no.
Exactly right. Yeah, so they're doing it here. It's actually was on the ballot today. Thanks, Critical. Okay, Addie says I'm gonna try and learn algebra 2 for summer this winter. I've seen locked up toilet paper. Yeah, what? It's like messed up. Excuse me. Okay. This one was fun. I think this was a cool one. What grade are you in, Addie? Like, what grade are you in? What math are you in right now? You know, what are you learning? Because I can tell you what you're gonna learn next.
Nothing.
Nothing. Absolutely nothing.
You will learn nothing, and you will like it.
It's very sad. But you're doing geometry. Okay, great. Okay, cool. All right, so this is good. This is a geometry question. You should know how to do this. In 8th grade, supposed to do algebra, but doing so usually you do algebra before geometry, right? It's algebra, geometry, then algebra 2, I believe. Yeah, right? Okay, cool. Yeah, that's what I thought it was as well. Ooh, nice, Sensation. Yeah, Sensation, did my description update on the YouTube live too, by the way? Is it correct now?
I didn't know it was wrong.
Oh, well, no, there should be a link there so people know, like, to join the Discord. Like, if you go to the stream, I don't know. Like, in school, I'm doing algebra. Oh, I see, but you're learning geometry on the side, Addie? Is that what you're saying? You're, like, trying to get ahead? Okay, that's cool. All right, let's try to do this question. This is a good geometry question, actually. I forget if we needed trig for this. Did we need trig for this? I don't think we needed trig for this. Yeah, I'm pretty sure we didn't. Okay. All right, so they say use the information given to find the length EC. Yeah, I don't think so, Cosmic, right? Yeah. Yeah, just, okay, good. So here's a good question, Addie. Do you know how the Pythagorean theorem works? Yeah, I'll at you, Critical. Okay, cool. All right, so you know how so you should be able to do this using the Pythagorean theorem. Let's try to do it, Addie. A squared plus B squared equals C squared, right? Yeah, correct. Nice. Yeah. A squared plus B squared is equal to C squared. And even more so, do you know about the triples? Have you seen these things before? 3, 4, 5, 5, 12, 13. And then what was the other weird one that there was? What was it? It was like 5, 17 something. One of them has 17 in it. Oh, you ain't seen this? Okay. Well, here's what I'm going to... you'll learn something here, Addie. Okay, so 3, 4, 5 is a unique... or not a unique, sorry. It is a solution to the Pythagorean theorem. So look, for instance, here if I start plugging these numbers in, all right? Notice how 3 squared plus 4 squared, right? That's 9 plus 16 is equal to 5 squared, right? This is 25, okay? you see how that works? What are we doing here? Oh, nice. Okay, thanks, Sensation. Yeah, that looks good.
It's
Okay.
not there.
It's not there? What do you mean it's not there?
It's if you like click on your channel and then come out of the stream, it's there, but it's not there during the live section of the exercise.
Oh, yeah. Well, it's not in the chat or anything. That's fine. Yeah.
Hello.
I need to get a chat bar for that. What's up, Zero?
I have like a question for I have a Calc AB test tomorrow. I need to know like what is the main difference between the product rule and the chain rule, like when to use it for a question.
Sure. No, that's a good one. Do you have any example questions? I mean, I can do example questions for you, but do you have any example like test review questions you have to do for it?
Sure. I have my teacher uploaded a test review
Oh, fuck yeah.
yesterday.
Okay, go find a question that like is difficult and you don't understand. Take a screenshot of it and then just put it in the screenshots channel, and then I'll get to it today for sure. And I'll teach you it.
Yeah. I'm on unit 3 for AP Calc AB this year.
Cool, dude. Cool. Yeah. No, we'll go through it. Yeah. I got a little bit of a queue of students I got to work through, but I will stay on streaming late tonight, so I'll get to yours for sure. Just make sure you entered in the queue somehow.
There was like a question in the test from like a previous test where I never figured out what the actual answer was. It was like a really long like question for the root of like the E. It's
Oh yeah, e
written
to the
in my
x.
notes.
Yeah, that's easy. I can show you how to do it.
No, it's so it has. Okay, so it says what is e to the power of 5 sine
Uh-huh.
to the power of like sine square 5x. I'll write it down if you need to.
Yeah. Well, yeah, get a picture of it. Screenshots. So for everyone that, people are new on my channel. It's totally cool. Oh, wait, that's Sensation. Fucking OBS. God damn it, you piece of shit. Sometimes it grabs the wrong Discord screen. Like, because I have you popped out in the chat somewhere else, and it'll pick that. It's supposed to show the Discord, but it's showing you on the Discord. Nothing wrong with you, Sensation. We love your face.
Do it again. Do it again.
Where can I submit the?
Hi, everybody.
Where can you submit it? Yeah, it's called Help Screenshots. There's a channel in the Discord called Help Screenshots.
Help screen.
It will only let you post screenshots. Yeah. So don't try to post text in there. It won't let you do it.
Look here. Right.
Yeah. What do we got here? What do we got?
It's
the
this key
prince.
here.
Yeah, we went over how that button is actually kind of dangerous for me though, because I have so many monitors. All right. Anyways, let me help Addie, and then I'll get through everyone's questions. Don't worry. All right, Addie. So we have 3, 4, 5. That is a solution to the Pythagorean theorem, which means if you have sides of a triangle, Addie, that are 3 and 4, the hypotenuse, right, which is always the longest side, is equal to 5. All right. Good job, Zero. I see it. Yes, exactly. And also the cool thing here, Addie, is that multiples of these work as well. Okay. So if I multiply this by 2, 6, 8, 10 is also a solution. And then if you multiply it by 3, for instance, right? 9, 12, 15 is also a solution, and so forth and so forth. Yeah, you can keep going. These all work. If you want to see like why that is, it's actually kind of cool. Yeah, it's not that it will be equivalent, it's that it'll work out. So look, for instance, so we know that 3 squared plus 4 squared is equal to 5 squared, right? Now let's multiply each number here by 3, for instance, okay? So let's say, for instance, instead of saying have 3, I have 3 times 3. Instead of 4, I have 3 times 4. One second, let me move this over. Let's go away. Yeah, let's say I do this. And instead of 5, I have 3 times 5. But these are all in parentheses, okay? The cool thing here is that 3 squared, right? This is like 3 squared plus 3 squared equals 3 squared, and then you have your original numbers here. So 3 squared, 4 squared, 5 squared, and then so all the 3 squareds go away. These all go away. Bing, 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 okay? And you get your original expression, okay? That's why multiples of like 3, 4, 5, 6, 8, 10, 9, 12, 15, these all work. So if you're ever doing things with triangles, try to look for these patterns, because I guarantee that your teachers are using one of these, because teachers want to be able to grade things easily, so they're not going to put weird numbers in it, you know?
No.
Unless like they're choosing violence in the morning. But, you know, usually they're not. So yeah, for this one as well, right? 10, 24, 26 would work. No. And then like 16, 30, 34. You really only have to know these two. This one like sometimes comes up, but this one comes up a ton. Okay. Anyways, let's look at this triangle right here, Addy. And they're asking us to find the length EC. All right? EC is going to be this length right here. Okay? We're trying to figure out what this is. And what we know, right, is that this angle right here is a 90-degree angle, okay? That tells me that this is 90 degrees, this is 90 degrees, and this is 90 degrees, and this is also 90 degrees. Yeah, right angle. Okay, so what does that tell me about these triangles here? What type of triangles are these? Right triangles. Exactly. And if they're right triangles, that means I'm allowed to use the Pythagorean theorem to figure out all the sides. We love that. Okay. All right, so looking at trying to find this side EC, right? We see, I feel like I'm back in 5th grade all over again. You did this in 5th grade? Excuse me? Well, that's advanced, bro. What? I didn't have to, dude, I was like eating Play-Doh in 5th grade. Anyways, okay, good. 0. I like that. I like the MS Paint screenshot. That's even better. Yeah. Okay. So we're trying to get to this, right? We're trying to get to this. And we have this. All right. So this is kind of like the triangle we're trying to solve for. Or at least one of them. We could also solve for this triangle, for instance, right? So yeah, let's try to do some stuff here. All right. So we know these are all right triangles. What do I need in order to use the Pythagorean theorem, Addy? Like, in order to solve for one side, what else do I need? You need the legs, right? Yeah, you need 2 other sides. You could have the hypotenuse. So let's look, for example, here, right? Do you see this triangle right here? I have 2 of the sides. I have one of the legs and one of the hypotenuse. I have the hypotenuse, not one of the triangles only have one hypotenuse. Okay. So then I could figure out what this side is, AE is. How would I figure out what AE is in like this triangle that's happening? Good. A squared plus 20 squared equals 25 squared. I agree. Good. Very nice. Okay, cool. So yeah, I know this. So A squared plus 20 squared is equal to 25 squared. Okay. Now, without using a calculator, Addy, do you know how you figure out what this A is? You're not allowed to square anything. You have to just kind of look at it. You forgot? It's okay. So let's look. This pattern here, A2025. What does that pattern look like? No squaring it. You're not allowed to square it either. No. You could, but I want you to see the fast way to do it. Okay? If Trump doesn't win, we're cooked. Oh, man. I don't know about that. I don't like the fear-mongering on either sides, you know? They say if Kamala doesn't win, that, like, everyone's going to get raped and can't have an abortion. And then they say if Trump doesn't win, we're all going to, like, get killed by illegal, whatever. I'm just like, y'all, like, chill. Okay. So, this should look like a pattern to you. Look, A20, 25. Let's remember our pattern 3, 4, 5. Does this look anything like this thing? Good. There you go, Addy. Yes, Addy recognized that, ooh, if I multiply this by 5, right, this would get me 15, 20, 25. And now you can see, Addy, right? The missing thing, the A, that's just going to be 15.
Nice.
Okay? So that tells you right away, without even having to do this math, you can just put in 15 for here. Okay, so this is 15. Okay, excellent. Okay, so now this triangle is solved. So we're just going to solve triangles until, like, something hits, I guess, basically. Okay, what about this triangle now, Addy? How could I solve for the legs of this triangle here that's happening? This one. Good. 17 squared equals 15 squared. Good. So you have 17 squared is equal to 15 squared plus b squared. Okay, fine. Does this look like any of our patterns? Dude, that Kirchhoff's law, dude, that won't be a nightmare sensation, dude. What? It does. What about this one? Addy, let's look at this one. Note that the order, the order of these two doesn't matter. It could be 15-8 or 8-15 as long as the short ones are first. Yeah, order doesn't matter, right? Because 8 squared plus 15 squared, that's the same thing as 15 squared plus 8 squared. Same stuff. Yeah. So what would this side be? What would this side be? Eight. Excellent, Addy. Yeah, so this side is 8. Okay. Now we have enough numbers to solve, right? Because remember, at the end of the day, we're trying to get side EC here. What can I do to figure out this side EC now that I have this number and I got this number? We're trying to get side EC. Trying to get this. We solve for the DEC triangle. Exactly. Good job, Addy. Yeah, exactly. This is now the triangle I'm going to solve for. Okay, how am I going to solve for it? (28 squared equals 8 squared plus b squared. I like that. Yeah, 28 squared. No, that's right. 8 squared plus b squared. I agree with that, right? Small side squared equals big side squared. Yeah, you're good. You're good. Okay, this one, unfortunately, is not any of the nice patterns that we know. So you just have to do this by hand. So, yeah. So we this one we can't, like, not cheat, but we can't take a shortcut. So we got to do 28 squared. That's equal to 784. Equals 64 plus b squared. We can subtract the 64. And then we can take the square root of that to get our final answer, which is 26.83. And you're done. Nice. Good job, Addy. This is so much easier than how I learned it. Awesome. Yeah, I'm glad, dude. Yeah, please. I mean, yeah, take more advantage of this, you know. I know you do a great job earning bond coins for the fitness challenge, and I know you also live in India, so it's fucking hard to wake up for the streams. But we may start doing streams at different times. But yeah, I'm glad you got something out of this. This is the whole reason I make everyone at least come to one office hours, because I want you to at least learn something. So, congrats, nice. I know what you want. You want Minecraft or something. I'll get it to you, if not tonight, because it's an election and I'm gonna be really busy tonight. I'll get it to you by tomorrow. Don't worry. I'll get it for you. Cool. Yeah, you're very welcome. Thank you. All right. Okay, cool. Let's see. We got a lot of questions today. Addy's done. Let's see. Ace, are you in the house? Then I got 1K. I got Lost in Saga, and I got 0. Yeah, you're very welcome. Have a good day at school, man. Yeah, Addy woke up at like 6 a.m. this morning to come to our stream so that he could ask a question before he gets ready for school. That's super cool. I love all the wide array of students we have all over the world. It's awesome. Okay. If Ace is not here, oh, someone told me to like ping them or something. I woke up 2 hours early because I got confused. No, you're totally okay. Addie, and I appreciate you doing that. Yeah. It's because, well, first of all, you're in a weird time zone. Your time zone is like a couple hours and a half. Like, it's super weird. Usually time zones just add an hour or two, but yours adds like a half hour. And then to make matters even worse, Addie, last week we had daylight savings happen, which fucked up all of the schedules on Discord. It's super annoying. I noticed that too. When you said, like, wait, it says it's in an hour, I'm like, oh, that's wrong. So I went and I fixed it. It's all fixed now, but thank you for pointing it out to me. I forgot that Discord still doesn't fix the times for events past daylight savings. They really should. Yeah, UTC plus 5.5. Yeah, it's weird. What? All right, what's up? 1K is here, or I'll do Lost in Saga, or I'll work with Zero. You know what, Zero? I'm gonna work with you right now, just because you're here. Is that cool?
Sounds good.
Nice, let's do it. All right, cool. Let's go. All right. Okay, 1K. I'll work with you. Work with you next. Let me work with 1K with Zero. He's here. Okay, this is a weird one. Yeah. I believe this is gonna be a chain rule, is what this is. You're asking, like, when do I use the product rule and when do I use the chain rule?
Yeah, I don't really know which one to use right now currently.
Okay, so you only use the chain rule when you have things multiplying by each other that both contain X. So an example for this would be, the vote counting has started. Oh yeah, we'll check it. So if we have, for instance, like sine of X times X squared, and I ask you to take the derivative of this, you have two different things with X in them, and they're being multiplied by each other. This is where you need to use the product rule. Okay?
Can it be like sine x times like z squared? Can that work or no?
Yes, but okay, so what what calculus are you in? Are you in multivariable?
AB.
Okay, so no. So if it's z squared, we don't care about z. Unless z depends on x, which I hope it doesn't.
No.
If z doesn't depend on x, this is treated as a constant. Okay? So you don't have to worry about it. Okay?
All right.
The only difference is if you're doing implicit differentiation, and then you do have to kind of worry about this. Are you doing implicit yet?
I finished implicit like a couple days ago. I remember like I found your channel because I was like staring at like examples for like 2 hours.
Yeah.
And then I was like looking for a quick summary of like 30 seconds, and then I found like you in one of those shorts. And I was like, how on earth do I know when to multiply like d or dy or dx like in any of the questions? Because I was like staring at it, and I was like about to have like a breakdown. I was like, I'm gonna wake up at 3 in the morning and study this perfectly because I'm like way too asleep. And then I looked at your questions and everything for like 10 minutes, and it helped a lot.
Oh, fuck yeah. Yeah, it's the one time like doom scrolling at 3 a.m. like works out for you, right?
I was so like I looked over like 15 YouTube videos to find like an example.
Oh wow.
And right now I have like an entire like unit to go over.
That's
for
fine.
tomorrow's test. We went over like 2 days ago derivatives of the inverse trigonomic functions.
Oh, those ones suck.
So
yeah, like arcsine and arctangent.
Like an hour ago, like every once an hour, I was actually like testing myself to remember all 6 identities of arcsine, arccosine, arctan, arcotangent, arcsecant, arcosecant.
Is this what is ddx a sine negative 1 of x? Is it 1 minus x squared? Is that what it is?
Well, no, it's
I forget which one.
well, in the example it says arcsine u, so the
Oh.
formula for it is u prime divided by square root of 1 minus u squared.
Oh, okay, yeah, I'm just missing the square root, yeah.
Yeah.
And then, yeah, where they're doing, yeah, so instead of u, I wrote x, and then, yeah, dx. And then the reason why they're saying u prime is because if what you're taking the derivative of here, let's say this, right, has a bunch of, like whatever stuff in it, you have to also take the derivative of what's inside afterwards. That's why the thing is this. It's 1 minus u squared, and then they say like u prime. So they say like
That would
box
be 2x
square.
in this case.
Good. Yeah, you have to take the derivative of what's inside. That's the chain rule part of this. Yeah. Have you seen my video on the chain rule?
I think so, but like I
Yeah.
haven't gone over like since like 2 weeks ago. We
Okay.
had a hurricane just hit in Florida, so like we
Oh,
got
fuck.
like really behind him. We got really behind.
No, I got you. You're totally fine. And like, yeah, College Board doesn't give a shit, right? They just say like, keep moving. So mad.
Yeah, I had like
Sucks.
a load of exams after the hurricane.
That's fucked. Okay, here, let me help you with this example, and then along the way, some things should click. All right. So whenever I see like some complicated shit going on, right, I want to try to write it in what I know is the simplest thing I know how to take a derivative of. Okay? So I see like e to the like all of this scary garbage, right? I'm going to just pretend that all of this is just like a box of things, and just I'm not going to worry about what's inside, okay? What do I know is the derivative of e to the something?
It stays the same, I think, for the derivative, because like e to the x derivative
Good.
is e to the x.
Good. It's e to the x, right? So it's e to the same thing, but then you have to multiply by the derivative of what that thing was that you ignored. This is the chain rule.
Yeah.
So you pretend whatever's inside here, you don't even look at it, and you say, okay, what's the derivative of e to the x? The derivative of e to the x is just e to the x. So the derivative of e to the whatever the hell's in here is just e to the whatever the hell's in here. But in doing that trick, in doing that, like, you know, you have to pay it back. You still have to take the derivative of what's inside of there. Okay?
Yeah, I think it's like I think you first do the sine square and turn it into a cosine square, right?
Well, so this is actually this is gonna be this is a double chain rule, unfortunately. Like your teacher really messed with you here. Okay.
There was an example that I saw.
No,
like,
no. It's
of,
tricky.
like,
This
a
is a double chain rule. Okay, so this is 5 sine squared. Actually, this is a triple chain rule. Wow. Okay. I'll show you why.
Yeah,
it
I
is.
spent
Okay.
like 20 minutes in the class exam doing that, but I already finished all the questions, and this was like one of the first questions in the test, so I skipped it completely.
No. Yeah, this one sucks. Okay. So anyways, so e to the whatever is the same thing as e to the whatever times the derivative of what that whatever thing was, okay? So I can replace this, right, with what this was now. So I'm going to say, cool, this is 5 sine squared of 5x, okay? That's in the exponent, yeah? Oh, I need to make some room. We're going to have to make a lot of room because there's a lot of stuff going on here. Okay? And now I go to work on just this, okay? So don't even worry, don't even look at what's happening back here anymore. We're just focusing on this. Okay? So now I have to take the derivative of 5 times sine squared of 5x. Okay? The first thing you kind of want to do is to see if there are any like multiplying constants you can just pull out just to make this thing look a little easier, okay? So looking at this, are there anything just multiplying through that you could just pull out?
You can pull like sine square, can you, right?
No, sine squared is a function. And also sine squared like has stuff happening to it. What about 5 here? You see how it's just 5 times this?
Yeah, it's like
You can
5x squared.
You can pull the 5 out in the front. You understand why that is? Here, let me show you. Okay. Let's say, for instance, I want the derivative of 20x to the 4th. What would that derivative be?
80x to the power of 3.
Good. Now, okay, let's say instead of like leaving the 20 in there, I put the 20 out front. And then I just take the derivative of x to the 4th, and then I multiply by 20 afterwards. Do you see how you kind of get the same thing, right? Because this becomes 4x to the 3rd, all times 20, which is then 80x to the 3rd. Right? Doing this derivative gets me to here, and then the 20 comes in and gets me the same answer. Did you know that? It's okay if you didn't.
Where does the x to the power 4 come from? Is that like an example of like a separate thing?
Yeah, it's a totally separate example. Sorry. Yeah, this is
Okay.
not related. I'm just trying to show you like how things work.
Yeah.
Does that make sense though? Does it make sense if you have something just multiplying, you can pull it outside the derivative, and then
Like
just multiply.
a coefficient specifically, it's like, so the
Yes.
5 is separate from the sine x, from the sine square.
Good, but the sine squared is not separate from the 5x. The sine squared is acting on the 5x.
But the 5 isn't.
The 5 is kind of part of the story, and we'll get to it. Okay, so let's look at this, for instance. Okay, this is where things get a little tricky because it comes down to how this is written. This tends to kind of mess with students. They're like, wait, why is it sine squared 5? You know, this looks fucking weird. Really, what this is saying, this part right here, this is the same thing as saying d dx of. Here, let me do different colors. Sine of 5x, and then it's all of that being squared. Jeff with the trolls. Okay?
Yeah.
All right. So, yeah, instead of writing that, I'm going to rewrite it like this cuz it makes it a little bit easier to see the chain rule aspect of it, okay? Okay, so now I'm taking the derivative of, again, some hot garbage here squared. So what I'm going to do is I'm going to pretend that I don't even care what's inside here. I'm just going to say what's the derivative of some nice little pink box squared?
It's like 2 times the pink box to the
Good.
power of 1.
Exactly, good. Yeah, so this becomes, right, yeah, 2 times the pink box to the power of 1, right? Times, we still have to do the derivative of the new pink box. Right? Because that's always the cost. The cost of us simplifying this is that I still have to go, take the derivative of what I just like blocked out. Okay? It's like if you eat a bunch of pizza, you're going to have to run eventually. Like, you can be like, oh, I'll just eat whatever the fuck I want now. It's like, okay, but you're going to have to go exercise eventually. Like, we're kind of just like kicking the can down the road. We're doing this with derivatives. We're doing all the simple stuff and then delaying actually doing the full derivative next. Okay? So, this whole thing here, right, became 2 times whatever the thing was to the first times the derivative of the pink box, okay? So now I can replace the pink box with what it was, right? So this is 2 times sine 5x, and that's all to the first, right? Which is the same thing as just 2 times sine 5x, right? Or really, it's only the sine 5x that's to the first. I mean, the 2 isn't to the first. So 0. This came down, right? And then the power became 1. And then, so that's 2 sine 5x. Did I lose you here?
No. I'm
Okay.
just like so confused how you got a times 5 at the beginning, like.
Oh, I pulled the 5 out. That was from here.
Yeah, like, but how can you let it, like, how does it allow you to pull the 5 out? Like, what can be proven to, like, let you do that?
So I haven't pulled this 5 out yet. This 5 has not been pulled out yet. The 5 we're talking about, the one here, that comes from here.
So, like, that's, like, basically... Let me think about it. So, it's
okay.
like... Okay, so basically, you did a pink box next to the 5. So 1 minus 1 is 0, so 5 times 1 is 5, yeah?
Wait, say that again?
So basically, you put the pink box right next to the 5, and basically the derivative of that. So it's like 1 minus 1 is 0. So the exponent turns out.
There are a couple pink boxes. Box 1, 2, or 3. Which one?
Like, okay, so the original question right here, the e to the 5 sine square 5,
Yes.
that right there.
Yes.
Let's say like you put a pink box right next to 5 completely.
Oh, okay. Okay. I see what you're saying. All right, you're saying if I did.
So like 1 minus
this?
1, yeah, 1 minus 1 is 0, so that turns into a 1, and that's 5 times 1 equals 5. That's what he did, right?
Where are we getting the 1 minus 1? Sorry.
Because everything in total is like to the power of 1 for the sine square 5x to the power of 1, the entire thing. And then like you did 1 minus 1, so it turns into like to the power of 0, it turns into a 1 always, so it's gonna be 5 times 1. And then that's where you got the 5, right? And then you put the times
Are you
derivative.
talking about like, are you doing the product rule here on this? Is that what you're doing? No, right?
No.
No. Yeah, Jeff is
Let me
right.
write it down
Mistaken
real
use of.
quick.
Yeah. I'm curious.
it.
I'm trying to see where you're getting the 1 minus 1.
All right, I'm doing MS Paint right now. Hold on.
Yeah, MS Paint, dude. It's okay, dude. Take your time, man. We'll get it. But trust me, this is a tricky question your teacher gave you. It is tricky. I should have used different colored boxes, honestly. I'm tempted to do it with different colored boxes. I have a lab report due today, and I cannot even read my lab partner's handwriting. Blame the fact that no one uses handwriting anymore. Why don't they type it up?
Hold on. Okay, I'm gonna send it like right now.
You're good.
So the circled is what like I'm doing the derivative of practically. It's like 1 minus 1, 0, and then this turns into a 1, and then you put times dy over dx, and that's what I got here.
Okay. Yeah, no. This is wrong. This is not all to the first power. Really what's happening here, this right here, this is sine of 5x all to the second.
Yeah.
It's not that this is to the second, this is to the first. It's the whole thing is to the second power. That's what's confusing about sine squared of 5x. They write it like this. They write sine squared 5x like that. But really what this means, this is the same thing as sine of 5x times sine of 5x, which is the same thing as sine of 5x all squared. That's what this thing means. It's not this is this is this. That's wrong. Yeah. This fucks with kids. I get it. I know why it does.
Can I see the process one more time real quick?
No, we're gonna run through the whole thing because I was using the same colored boxes for things and that's confusing. Okay. All right.
Can you go back to the colored boxes real quick?
Yeah, I was gonna do new colored boxes because this gets kind of confusing because they're all the same color.
The only thing I didn't understand is where you get the times 5 times the derivative.
Oh, right here?
Yeah, that's the only thing I didn't understand.
Oh, okay, cool. Let's just wipe this. All right, fine. Okay. So, so e to the this, right, is e to the this times, and then it's ddx of whatever this was, right? So that's ddx of 5 sine squared of 5x. We'll get this. Don't worry. I know this is tricky, but I want it to click. It will click. It just takes time. Let me move this over. So here. So we were taking the derivative, right, of e to the 5 sine squared of 5x, right? Do you understand this part, 0, so far?
Yeah.
Okay, cool. I'm going to show you where the 5 comes from. So we have e to the box. Good.
I understand you pull it out, but I don't understand like how you're able to pull it out, like how they allow you to do it without like getting it wrong.
Okay, I'll show you. So e to the this is e to the this times the derivative of this. Okay. Now let's just look at this part. Okay. This is ddx of copy, come on, girl. Of this, yeah?
Yeah.
And you're wondering, how am I able to take this 5 and just put it here?
Yeah.
Oh, yeah. That's just a multiplicative. Anytime you have something multiplying and it's a constant, you can pull that multiplying constant out.
How
out
come
front.
it just doesn't turn into 0?
okay, all right. So let's pretend this is the chain rule. Do you want to pretend it's a chain rule, for instance? Let's do that. So let's pretend I have d dx of 5 sine of x, and I'm gonna treat this as a thing, right? And I'm gonna treat this as a thing. Okay. So this is good. This is a good review of the chain rule. So when I take the derivative of something times something, what does the product rule tell me to do?
The product rule formula is what you're asking, right?
Yep. And the reason why you have to use the product rule here is because you have two things multiplying by each other.
The product rule is f prime g
Good.
plus g prime f.
Good. So it's the derivative of the first thing, right? So d dx, or here, let me put different colors for things. So it's the derivative of the first thing, right? Times the second, plus the derivative of the second thing, right? Why is dxy not dxdy? It just isn't. I'm sure there's an explanation for why it is. I'm just telling you the rules. The proof of the product rule is interesting. Yes, Jeff, show them where the proof is. Okay. Okay, so here it is, right? So derivative of the first thing times the second, right? Derivative of the first times the second, plus the derivative of the second thing times the first. Does that make sense so far?
Yeah.
Good. What is the derivative of 5?
0.
0. I don't care what this is. 0 times whatever, this is all going to go away.
Okay.
Does that make sense?
Yeah, 0 times sine x is 0.
Cool. Okay, so now what I'm left with is the derivative of sine x all times 5, right? Do you see how this is the same thing as 5 times the derivative of sine of x?
Yeah, it's the 5 times 5 cosine x.
Okay, do you see how that's the same thing here as when I'm taking the derivative of a constant times sine of x, I can just pull the 5 out in the front and then keep doing the derivative. It's because if you were to do the product rule, when you do this derivative of a constant, this thing goes away. And you're just left with the constant being multiplied by the derivative of the rest of it.
Does this apply, let's say, towards cosine x times sine x? You can pull the cosine x out of...
No.
No? Only towards
The-
constants?
The only thing you're allowed to pull out is a multiplicative constant.
Okay.
Yeah.
So
If it has
pi
x,
works.
pi works. Yeah, anything that's a number, totally fucking cool. If it has x in it, no, you can't do it. Can't do it. Only things that are just numbers.
E.
E's totally cool, as long as it's not
Okay.
e to the x. If it's e to the x, you can't.
ln.
As long as it's not
That's
ln of x, it's got to be ln of a number. Just like, I don't know. Just like, is your x there? Don't go. Yeah.
Natural log. I don't remember natural log exactly.
Ln is the same thing as just log. It's just base e. It's like whatever. Okay.
All right.
Okay. So we're cool with like pulling this 5 out.
Yeah,
far?
I just like... Okay, if
We-
it's a constant...
Constant, we can pull it out.
If you can just pull... Alright.
Yeah. Okay. Only if it's
like a
multiplying.
shortcut.
It's a shortcut. Yeah. Well, it's a shortcut you want to know because otherwise you're going to be taking a really long time to do these questions. Okay. All right. So now I'm taking the derivative of sine squared of 5x, right? I'm going to rewrite this as the sine of 5x all squared. Okay? Just because it looks better to me, okay? Now, what I can do is I can say, okay, this looks, again, confusing. I'm taking the derivative of sine, and it's also sine of 5x, and then also all that shit's getting squared, right? So I'm, again, just going to, like, put a bag over my head and say, like, I don't want to look at that shit. I'm just going to call it a box. What's the derivative of something to the second power?
2 times. Can you like possibly undo like what you erased? Because I want to take a screenshot of that because I might forget about it.
I'll take a screenshot of the whole. Oh, which part?
Like the thing you were explaining about the constant operative. Like I want to take a screenshot so I can like memorize, so I can like not forget about
this.
that. Yeah. Can you control Z or no?
No, it's gone.
Oh man.
Oh, here, I'll show it to you real quick. It's what was it? Okay, ddx of 5 sin x. Okay, that's ddx. It's not gonna have the colors. Sin x times. And then this goes to 0. So now you're just left with 5 times ddx of sin x. Yeah? Like a little bit better?
Hold on.
We're gonna like put some colors.
How come like when you're doing the derivative of sin x, it's not just dx times dx?
You mean here?
No, like you said like in the implicit differentiation, you said
Yes.
it would be sin x times dx.
It would be, yeah. But we're not doing implicit here. We're just doing straight derivatives. If I'm doing implicit derivatives, then yeah, I need to write like it would be sine of x dx. Yeah, you're right. I would need to do that. But this is not implicit. Implicit is when you have the variables kind of all like schmattered about, and like for instance, you have like y's and x's like connected with each other on both sides. Like this. And you're like taking derivatives over. You're taking like what I call like half derivatives because you're not doing the full thing yet. And then you're rearranging things to get dy over dx. Here in this example, like how this is working, I have y is equal to 5 sine of x. So when I say dy dx, I don't need to account for y popping up anymore, and I'm just literally just doing fucking move. ddx of this. So this the where I would usually put dx, that's already been taken care of. Yeah.
All right.
This is not implicit. Implicit is when x and y are like on a bunch of sides and you're just trying to figure it out.
And quotient rule is completely different from like the implicit differentiation. Quotient rule is like
Yeah.
product rule but longer step.
Yes. Yeah, you can also write the quotient rule as the product rule and the chain rule if you really want to. It's another way to do it.
Can
But
you
here.
turn the product rule into a chain rule?
No.
Oh.
Yeah, no.
Only quotient rule?
The quotient rule can be represented as the product rule with a chain rule.
Yeah.
I'll show you how in a bit. It's okay. Let's do this though. Let's get here so far, right? Yeah, exactly, Jeff. So I agreed that I could pull the 5 out, and then I have of sine squared 5x, but I'm gonna write this as sine of 5x all squared. Okay. I understand why this is tricky, especially for like your generation, because you have to keep in mind like a lot of things that have happened in the past. Like if your attention span is shot, you're going to get fucked on this because it's so hard to remember like, wait, which one was I doing the derivative of? I totally get it. I understand why it's confusing. And especially when like TikTok is just like blasting you with like, go to the next thing, go to the next thing, go to the next thing. It's okay. Like I know why this is tricky. Okay. But let's see, right? So I now like just don't think about stuff behind, just think moving forward. That's why we've written everything down so far because we'll come back to it. I need to take the derivative of sine squared of 5x, which is the same thing as taking the derivative of sine of 5x all squared. This is a complicated thing. I don't know how to take the derivative of all this stuff going on. But I do know how to take the derivative of something squared. What is that going to give me?
2 times the green box.
Good. Okay. And then what's the thing I can't forget? What's my price for doing that?
Times d over dx.
Of the green box, right? Okay.
Yeah.
So this equals 2 times the green box times d dx of the green box. Okay? So now we can remove the green box, right?
Yeah.
That stays like that. Okay. And now we're taking d dx of the green box. So d dx of sine of 5x. Okay? And you have to remember that this 5 out front here, right? This 5 is gonna like eventually multiply through everything here as well. Okay? We'll put it all back together at the end. Okay. So now I move on to my next derivative, which is here. Okay? Now I'm taking the derivative of sine of 5x. Do you know what the derivative of sine of 5x is?
Cosine 5x.
It is. Okay, so close. So you know the derivative of sine of x is cosine of x. So you can do this again. I can take, I wish these boxes would default to, okay. You can take this, right? We know the derivative of sine of box, right? That's equal to cosine of box, right? But again, the price for doing this is I still need to take the derivative of the box. Okay? So now that's cosine of 5x times the derivative of 5x. What's the derivative of 5x?
5.
Good. This is just 5. Okay. Now, we have to put everything back together. Okay? So, here, I'm going to copy this all onto a new page. What the fuck was this? Okay, whatever, this can go away. Okay. Okay. So, we knew that all of this, right, was equal to 5. Yeah? d dx of 5x was 5. So I can get rid of this and pull up the 5. Okay? Ugh, move. Okay? Which is the same thing as 5 cosine of 5x, right?
Yeah.
Okay? Now, all of this, right? The d dx of sine of the box and all of that, that's all this. So all of this now goes away. And this comes up. Okay? Now, all of this was this. So now this goes into here. We get rid of this. So d dx of sine of 5x squared, right? That was all of this. So the 5 is going to be multiplied by the 2. So that, well, we'll just leave it as 5 for now, okay? And then all of that was my d dx of this pink box, right? So then all of this is going to come up here. Okay? And then we can remove what this pink block was. So then this is your final answer. Oof. I know. So this is where you can start combining some things. You see how I have like 5 times 2 times 5?
Yeah.
So that's going to be 50. And then you have e to the 5 sine squared 5x sine of 5x cosine of 5x. And then this is your final answer.
I have like another question, but I have to walk my dog, so like I'll have to be back
You're
like in
you're
30
totally
minutes.
cool. Yeah, I gotta help some of the students too. Yeah. Does this make a little bit more sense to you? Like you have to keep going. This is a very cruel question, by the way, because did you see how like it was a triple chain rule? You had to like keep going down, 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 down.
Yeah,
Until you
the
got to the
test
end.
was 4 questions, so that was 25% of the grade.
And I understand.
seems like-
I understand. Yeah. Well, your teacher's lazy, and they just want to put like one super hard question. Wait, sorry. Did you find me on TikTok or YouTube?
YouTube.
Okay, here. I'm gonna give you my I'm gonna post the link to the chain rule question that I did it in. Where was it? Here we go. Chain rule. Here we go. Complete guide using the chain rule. Cool. Yeah, I just reposted this one a day ago. Here's how to understand the chain rule. But here's a 3-minute thing where I go through like using the boxes and whatnot and how it works. And you can actually see I kind of use I think a similar question to what you had, which I think was yeah. Do you see here? I did sine cube 10x squared. Yeah, the only thing I was missing was like an E to the X in there.
Yeah.
Okay. So watch that video a couple times, late at night. Might help out. And then I'll attach the PDFs of these as well so you can have them. And then, yeah, feel free to come back. I should still be streaming, and we can go over more stuff. Is that cool?
When are you gonna stop streaming?
I have to stop streaming in 2 hours. I have to. I have a hard stop in 2. But I'll probably be streaming at least another hour and a half.
All right, I'll be
Cool.
back.
All right, cool. All right, good job, man. Yeah. Go walk the dog.
Well done! Well done!
Nice. Okay, cool. Ooh, that was it's a hard concept, and honestly, that's a tricky question. That's a triple chain rule. Like, why would you give a triple chain rule? Man, just like not nice. Okay, let's see. Who's saying predict it has Trump at 60% now? That's interesting. I thought they had him at 50 earlier today. How? Are they basing this off exit polls? Exit polls are terrible. No one's going to admit they're a racist. But I guess if they're Z Kyle, you can say Z Kyle. God damn it. Oh, this is just people betting? Yeah, if you want to see some interesting things on betting, right? We have a couple markets, right? Okay, so we got predict it. Damn. Okay. That's pretty damning. Okay, let's see what Polymarket has her at. Keep in mind this is a little biased because it's Crypto Bros. Ooh. Oh, whoa. That is a spike. Wait, what happened? Betfair is a British one, but we can't get there from here. Sensation can. Damn, yeah. See, yeah, Betfair, I guess, is what we're looking for. Betfair. Jesus, what happened in the last... That looks like the last hour. Jumped from 58 to 69. What's up, Equity? Good to see you, man. Oh, just watching democracy. I mean, technically, this is democracy at play. Like, people are voting, so... all right, let's look. Yeah, Trump's going to win? Well, I don't see any big upsets yet. Why is Texas going blue? Yeah, I know he has more votes, but so in order for Trump to win, he has to take swing states, right? Which means he needs to take Pennsylvania, which he is massively down in right now. We knew he was going to take Florida. Florida has been a safe thing for him. South Carolina and North Carolina are also big swing states. Yeah, the reason why Texas is weird is because they're probably counting all the cities first, which are very Democrat, very liberal-leaning. But Texas is a lot of land. So that means that there are a lot of people that their votes aren't going to get counted for a bit because they live in the, the countryside. Equity asks, why isn't there any info on Cali? Yeah, polls are not closed yet. It's 5 o'clock over here. So we still got 2 more hours before they close the polls. So they don't start counting votes until the polls close, which is in 2 hours. I do not know why they're giving it. I don't know why the betting markets are so high on Trump right now because he's losing in the swing states he needs to win. He needs to win Pennsylvania. He needs to win North Carolina. He needs to win Georgia. It looks like he's up in Georgia. Yeah, okay. We'll see. Exciting times. Okay. Texas is weird. 1K, do you want to do your question? If he loses those swing states, does he mean he's going to lose? Yeah, most likely. It's unfortunate how the Electoral College works, But yeah, elections at this point have come down to like a chess match. There are certain key states you have to win, and if you win them, you end up winning the entire thing. All right, 1K, let's do yours. It's not cool. Yeah, according to 538, no major upsets. I agree. Looking at the map, I don't see anything serious. I did vote. Yeah, I definitely voted. Yeah, I voted today. Although, like, what I vote for president doesn't matter because California always goes Democrat. It's just so solidly blue. Are you allowed? Yeah, you're allowed to tell people who you voted for. I did not vote for Kamala, and I did not vote for Trump. I wrote in a candidate because I cannot vote for Trump. He's a terrible fucking person. But I don't support Kamala either. I don't support what the Democratic Party is doing. So, whatever. And people who get mad at me saying that a write-in candidate is a throwaway vote, voting anything in California is a throwaway vote because it is so solidly blue. It doesn't matter. I'll do yours next, Critical. 1K was first. Hillary was up 70% and predicted, so you never know. Yeah. I don't know. But Critical, I think I will do yours next. Or, yeah, you are next. Okay. Did I say Kamala was going to be a good president? No, I don't think I said that. I mean, I think, well, I don't know if she'd be a good president, honestly. That's the problem. The problem is, like, I don't know very much about Kamala because she doesn't let very many people know about her. I do think she's the lesser of two evils in that she won't, like, start doing batshit crazy stuff. I can make some arguments that Trump is a better president because he actually does stuff. The problem is that the stuff he does, I don't agree with. So, yeah, it's like defining like, yeah, are you good at your job? And then, like, is your job, like, doing good things for humanity? Oh, wow, thanks, Sam, for the resub. Yeah, Ace, I'll ping you. Yeah, I pinged you earlier. I didn't know you were still here. Okay, 1K, how do we do this? Find the range. You said something about she isn't relatable, but she's a good candidate. No, I think she's a terrible candidate. She's a career politician, which means in terms of being a politician, she's a better politician than Trump for sure. I just don't know if, like, traditional politician is what we need these days. 4 more months, so I gotta make more badges. Yeah, thanks, Sam. I'm gonna have to do it. Wait, don't I have a badge? What's my badge? I have the 36, right? Yeah, I already have the 36. Okay. Yeah. You'll get the 36. Oh, because I'll have to make another badge for myself. Yeah, you're right, too. Yeah. Okay. What is the range? Okay, cool. It's a good question, 1K. What's the range? What is the range of a function? How do we define the range? Thank you, Sam. I know Sam's back in the stream because Sam's making me drink. I'm going to be drinking a lot tonight. Thank you, Equity. Yes, it is the Y values, right? Yeah, North Carolina is a swing. Yeah, exactly. Yeah, we'll see. North Carolina's a bit. That's my hometown, actually. Not my hometown. That's my birth town. I was born in North Carolina, actually. Yeah, so we're saying, like, what are the Y values this touches? Okay, cool. It's a pretty cool question. Yeah, sorry, I was born in Chapel Hill. Sorry, my home state. It's my home state. Jeff's always keep me honest. All right, at 1K, you gotta tell me. Equity's like, just get this fucking question out of here. He's like, I already know it. I get tired. I need coffee. Zero to -9. Okay, close. I mean, 0 is all you see on the graph. I agree with that, right? You just see 0 here. Yeah, you just see 0 to 9. But really, this graph, like, keeps going up and up. Okay, all the way up. What's up, the workaholic? You want to say hi? Okay, cool. You say why. What's up?
So, you alright?
What? Yeah, what's up? What's up, dude?
Yeah, I'm watching the polls. Nothing much.
Nothing much. Yeah, yeah, the poll. I think nothing crazy has happened in the polls yet. I think.
Yeah.
Yeah, we're kind of just standard. Nothing crazy yet. Nothing crazy yet.
Yeah.
Let's see. Okay, so 1K. Yeah, it goes past 0, bro. It goes all the way up to positive infinity. Okay, when you're looking at the range, you got to see what are the lowest values of y, what are the highest values of y, and then you got to list it from low to high. In this case, the lowest it drops down to, right, is -9, and the highest it goes up to is positive infinity. Dr. Gold, is this gonna be a 2-hour stream? Yeah, probably at least, because I still got to help a lot of students today. Yeah. Might be a 3-hour stream, honestly. No, wait. Yeah, it might be 3. Okay. Yeah. So here's a good question. Yeah, of course. Yeah, ask a question, dude. I'll do it. As long as you're awake, I'll do it. All right. 1K. How do I write this in interval notation? Do you know how to write this in interval notation? Like going from -9 up to positive infinity? How do I write that? You don't know? Okay, that's fine. Okay, so you're going to put a comma, right? This is always the low number. This is always the high number, okay? And then you need to use either a parentheses or a bracket. You will always use a parentheses with any of the infinities. Parentheses means it can't actually equal that. And we use this with the infinities because nothing can actually equal infinity. Infinity is like an abstract concept. It's not a real thing. It's like a bajillion whatevers. Like it's bajillion gazillion something. So you always use parentheses. You use a bracket here on -9 because this can actually equal -9. Okay, do you see how there's a solid, the graph actually touches -9. So that's why you would put a bracket here for the -9. Okay. Does that make sense, 1K? I'm going to give you another question because I want you to actually do it. Okay, no one help 1K. 1K's got to solve this on their own. Yeah, one sec, guys. Here we go. Okay, here. I want you to tell me what's the domain. Oh, this is a very big pen. What is the domain of... Let's do an easy one first. Well, actually, they're not all really easy. Okay. Let's do the domain of this one. Or sorry, the range. Yeah, let's do the range. Well, you should know domain as well. How do we do the range of this one? Here, we'll put some numbers. This is -1, -2, -3. That's 1, 2, 3, 4, 5, 6, 7. So this is -7, comma, -3. That's the point. I'm just going to give you the points for things. And then this point here, 6, is 0, 6. So he says 6 to infinity. Oh, 6 to negative infinity. Okay. A couple things here that are a little bit wrong. So you wrote 6 negative infinity. Okay, first of all, you have to always write the lower number first. I know you see it like, oh, it's 6 and it goes all the way down. You always have to write from bottom to top, right? Lowest number to highest number, okay? So you would want to write -6 infinity. Now, this is where this is tricky. It's technically not negative infinity because the graph here, 1K, the graph stops here. If there was an arrow, that would mean it keeps going down to negative infinity. Okay? Open circles mean not included. Yeah, thanks, Jeff. Okay. So this stops right here. Okay? You were good with the 6. I agree with the 6. The 6 is cool, right? That's the highest this thing gets to. Okay? But what's the lowest it gets to? Cosmic's getting kind of close. -7, -3. That's the point, okay? But remember, range is concerned with the y values, right? This is always the y values. Okay? Which one of these is the y value? Hey, Cosmic, I think you want a bracket on both. 0, 6. Well, no, 0, 6 is this point, okay? The y value, right? This thing goes all the way down. Yes, I agree with that, yeah. This goes all the way down to -3. And it goes all the way up to +6. Ugh, can't move it. Okay. Do you see that? Yeah, the 0, 6 is the point. That's what the point is. The point is 0, 6. But you want to look at where the y values are. So the range for this one would be -3, 6, and then you put a bracket around both. Because there's a solid circle here at y equals -3, and then 6 is a part of the graph. So that's why I put a bracket. Okay? What about this one here? 1K. This is 7, and then what's that? 1, 2, 5, 6, 6, 7, and then this just like keeps going. Okay. What would we say is the range for this one? Or it's 6, -7. Sorry, I put the wrong. I forgot the negative. Uh-oh. All right, how do I write this one, 1K? Where is it? Oh, man. 1K, where'd you go, baby? Where you at, dog? You got to be present to answer the questions. So the y-intercept, I don't care about the y-intercept. We want the range. We want the range. What is the range, 1K? Range. What is the range? The down distance is -7. I like that. That's cool. Down distance is good. Yeah, okay. So yeah, it starts -7 down. -2, -7 is not really what we want to deal with. No, I agree that the y-intercept is it's close to -2. It's not actually -2, but that's not information you want. That's just like saying garbage. You're just like saying random numbers. Like it's like if someone asks you, "Hey, do you want cheese on your pizza?" and you're like, "Water is wet. I like lamps. Coconut smoothies are tasty." It's like, no, bro. Do you want pizza? What type of pizza do you want? Dun, 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 dun. We gotta remember, range is saying what is the lowest value, what is the highest value for y. If you get this one right, I'll let you go. But if not, you don't get any bond coins because then like you have to be actually learning to earn. Ooh, wait, yeah, okay, there we go. Yeah, come on, yeah, come on, pay attention. This question, yeah, what's the range? What is the range? So okay, ooh, okay, now he's going. -1. No, why are we saying those numbers? Why are we saying -1.75, -7? I don't think you understand what range is, which is important, 1K, because that's what your original question was, right? Let's look at this, right? What's the range? Because it's not exactly on the point. Yeah, but that's not what we're dealing with. Range is saying for a graph, right? For a graph, what are the y values that it touches? Y values are here. These are y values. It's not where does it touch the y-axis. It's saying how far down does it go and how far up does it go? Okay, Ace, here, I'm going to do your question. One sec. Ace, let me do your question. Ace, are you around? Range is not making any sense. And I'm running out of patience. Let's see. Aced. Or I will work with... Who has the next question? Lost in Saga? Yeah, I could do it with Lost in Saga. Oh, wow. Oh, you have different questions, Ace. Okay, Ace, which one do you want me to go over? You have been summoned. The second one? Okay, so the pendulums. All right, let's do it. Okay, a pendulum is 1.2 meters long. What is the speed of the pendulum bob when it passes through its equilibrium position? If it is pulled aside, it makes a 25-degree angle with the vertical. Hint, is it possible to determine the vertical drop of the pendulum and then use... Yeah, okay. Have you done conservation of energy yet, Ace? Yeah? Okay, cool. All right, let's do it. This is a very common problem that comes up a lot. Okay. So, we have... I'm going to do things to, like, exaggerate. Okay. And we know this is 1.2 meters long, right? Okay. This is 1.20 meters long. And then this makes a 25-degree angle. Ooh, okay, cool. Tricky, tricky. All right. This is 25 degrees. Okay. Now, because the pendulum stays the same length amongst all the stuff it's doing, right? As it swings, I also know that this is a 25-degree angle. Sorry, that this is 1.2 meters as well. Okay. So what I can do here is I can create kind of a right triangle, okay? And we can figure out what this distance is. Okay, so I'm going to figure out. So here, let me move this over. This is a very good question, actually. How do I figure out what this distance is from here to right here, which is like kind of, it's related to the height of the ball. How do we do that, Ace? Good. Yeah, exactly. Okay, cool. Yeah. So we know question mark is equal to 1.2 cosine of 25 degrees. Okay, that's what this is, right? All right. So, and this is the cool thing about conservation of energy is you can always measure your height from wherever. Like, you can call whatever 0 as long as it's the same in every single situation. So in this case, I'm going to call this h is equal to 0, right? So then how do I figure out this? Like the new height, h. What would that be? Good. Okay. Yeah, question mark, right? Yeah, we're trying to figure out h. Okay. So here. I measured the bottom. So I measured, let's call this the, whatever, like the pivot point. I said that when we measure, right, from the top of the pivot down to the end of the pendulum, when it's at the bottom, when it's, you know, at the whatever point, that's height equals to 0. And now what I want to do is figure out what the new height of the pendulum is. Oh, what's up, Don? Thanks for the raid. God bless us, everyone. God bless America. God bless the United States. What's up, Don? Good to see you, Don. I want to hop over to Penn Center's thing. How's this thing going? Shout out to Don Does Math. Don Does Math. Awesome guy. Ooh, okay. He says 1.2 minus 1.2 cosine of 25 degrees. Times 1.2 sine? Yeah, no, we don't need that. We only need this, right? We only need this, the height. So this distance here, which is the same distance here. Arkansas called for Trump. Yeah, that's not a surprise. But you're right. If this whole thing here, aced, is 1.2, and this is 1.2 cosine of 25 degrees, then h, which is like the height of the pendulum, the height of the ball at this point, that's equal to 1.2 minus 1.2 cosine of 25 degrees. The 1.2 sine of 25 degrees would be this distance, and I don't really need that. Does that make sense, Ace? This whole thing here is 1.2. This whole thing is 1.2 cosine of 25. So this, which is the same as this, is 1.2 minus 1.2 cosine of 25. Pardon, he says. Pardon what? Oh, gotcha. Wait, arc cosine is for Trump? Why is arc cosine for Trump? What? What's the joke there? I don't know that one. Okay. All right. So now we can write out conservation of energy. Okay. So it's pulled aside here, right? And then eventually it swings down to here. That's kind of what happens. It goes like, yeah, okay, cool. Like swings along this path, okay? So if we write out the energies, if it's held here and then it's dropped, it has no velocity. So kinetic energy equals 0. But potential energy is going to be mg times h, okay? Which we solved some things for that, right? That's mg times 1.2 minus 1.2 cosine of 25 degrees, right? That's the total energy here. Okay. Let's call it like... Now let's look at the energy when it hits the bottom, right? When this thing like comes all the way down. Now the height of this thing is technically 0, right? Because we're measuring the 0 height from this position. So now, Ke equals 1/2 mv squared. Ue is equal to mg times 0, which equals 0. And by conservation of energy, the totals here has to equal the total here. So that means that this number, mg 1.2 minus 1.2 cosine 25 degrees, needs to equal 1/2 mv squared. M cancels. Yes. Goodbye, M. Don't need that. Yeah, and then you can solve for v. V is equal to the square root of 2 times 1.2 minus 1.2 cosine of 25 degrees. And I think that's it, yeah? Is that the... I think, yeah, that's the correct answer. Okay, cool. Nice. Good job, dude. You're welcome.
Well done! Well done!
Yeah, this is a classic question that comes up in physics. It comes up all the time. I should tell Penn Center to do this in his mechanics journey, but they love doing this, and it's actually cool because it's a geometry question to be able to draw this as a right triangle and then solve for this and then know that this distance is this thing minus this thing. Comes up all the time. Okay, nice. All right, let's see who else we got. Is Kiss Killer or it's not Kiss Killer? Sorry, Lost in Saga. Lost in Saga, right? Is that his name? Yeah, Lost in Saga. Junior's next. Critical. Ew, capacitance. Oh, man. Okay, while I wait for him, I want to see. Let's see how the news is doing so far. Actually, let's go check out Penn Center. I want to see what Penn Center's doing. Where's Penn Center?
Like, I don't know. Can we talk about the whole like land acknowledgement?
Oh, he's
thing?
dressing
It's
as
so weird
Trump.
to, like,
Oh my God, Penn!
but I mean, individuals that are like from that region.
Where did he get the Trump wig, dude? Where Penn Center? Where'd you get this, dog?
I think it's cool.
Nice.
I like this guy too. I mean, like, if I was American, I probably
Oh, he's talking about
would vote
RFK. Yeah, that's too
if he was
funny.
running for president.
Yeah, he's a little problematic with some of his beliefs, but yes. Okay, all right, let's try to do this. Okay. Okay, a parallel plate
They have normal
capacitor.
beliefs.
They have what?
So they are normal beliefs.
I know, but he has some weird conspiracy stuff.
He personally probably has the most balanced viewpoint I've ever heard.
No, I do like him in terms of like all the FDA and the food stuff. It's interesting that Trump like embraced him because they clash so much environmentally. Like RFK is not for any of the drilling, not for any of the oil, and so it was a smart play by Trump because RFK kind of got ostracized by the Democrats for his vaccine viewpoints, and because of that, he was like, "All right, fuck you guys, I'm going to like Team Trump." I don't know, kind of speaks to my idea that I think we should be more understanding of people with different beliefs instead of like so quick to start yelling that people are either like racists or homophobes or I don't know, snowflakes.
But I am.
But I am. Okay, anyways, all right. Here, let me do some physics, then we'll
Well, that's what people will accuse me of, so fuck it. Just
fuck it. I am what I am. Okay, a parallel plate capacitor with this area and a plate separation of 2D. The left half is filled with this constant. The top right is with that, and the bottom right is with that. What is the total capacitance? Oh, this is pretty cool. Okay, so critical. The way to look at this is the same thing as two capacitors that are in parallel, I think. I think that's the way to look at this. So I have one capacitor here that's in parallel. And then let's use, well, here, let me use thicker things. Here we go. Okay, cool. All right. So we have this capacitor in parallel with a green capacitor that is in series with a purple capacitor. Does that make sense how I'm doing that? And then we're going to use some capacitance rules to figure stuff out, okay? Yeah? Okay. Okay, so this diagram looks it's like a funky Neapolitan ice cream sandwich of a capacitor, right? It's got like pink parts and green parts and purple parts. What I'm doing is I am taking this weird melting pot of a capacitor and I'm breaking it out into separate capacitors, which I see that, for instance, this block and this block all share the same positive plate and negative plate, which means I can break it up into the red one being in parallel with this mumbled mess of the purple and the green. But then the purple and the green are sandwiched between the plates and each other, so that puts them in series with each other, right? They're in series. They like kind of go in a line. Does that make sense so far? Cool. Okay. Okay, what we have to remember for capacitors in parallel. So capacitors in parallel, you have that the total is equal to C1 plus C2. For capacitors in series, C total is equal to 1 over C1 plus 1 over C2, and then all of that is raised to the negative 1. So it's interesting. Capacitors in series behave like resistors in parallel. Do you remember doing that in your circuits class? You know? Okay. So let's figure out what the capacitance of this whole thing is first of doing these two in series. All right. So I need to remember how capacitance and distance and dielectric. Okay, here we go. Yeah, that works as well. Yeah, critical. That works for if you have two things. That's a mathematical shortcut. I like that one. Okay. So this is the equation, which is that capacitance is equal to K epsilon naught A over D. Okay. So let's get the capacitances and stuff. All right. So C3, right? This one, which so here this is how this is gonna work, because we're really doing capacitor 2 in added with 3 in series, and that's gonna be, I'm gonna say capacitor 2 3. That's them combined. And then this one is going to be capacitor 1 in series, sorry, in parallel with capacitor 2 3. So C3 is equal to we'll put epsilon naughts on everything at the end, if that's okay. I'm just going to skip doing that. So that's equal to K3. The area is A over 2, and then the distance is D. So that's A over 2D. All right? And then C2 is equal to K2 A over 2D. And then C1 is equal to K1. Now it's still A over 2, but the distance is 2D. So that's going to end up equaling A over 4D. Okay? Good so far? All right, so now we just start going to work on this stuff. Okay, so I have... okay, so they all have an A over D in front of it too. Yeah. So here, let me just like redefine stuff. Yeah. So we'll just know at the end capacitance will equal to epsilon naught A over D, and then we're gonna simplify these things because I don't want to keep writing all the numbers. This is K3 over 2. This is equal to K2 over 2. And then this is equal to K1 over 4. Right? Okay. So C23 is equal to 1 over C2. So that's 2 over K2 plus 2 over K3 to negative 1. So you can see how you said, right, C1, C2 over C1 plus C2. You'll see how that kind of like comes around here because this has to get multiplied by K3 over K3. And then this has to get multiplied by K2 over K2. So then I get 2 K3 plus K2 all over K2 times K3. And then all of this is to the negative 1. So that ends up equaling K2, K3 over 2, K2 plus K3. Okay? That's equal to C23. And now that gets added to C1. So now I have... Yeah, all good. I'll give you the whole PDF for this too, man. So you can really zoom in on it. So then C total equals C1 plus C23, which is going to equal to K1 over 4 plus K2, K3 over 2, K2 plus K3. Okay. So I got to take this. I got to multiply it on the top and the bottom. That's so ugly. All right, whatever. This has to get multiplied by 2. So let's see. This is 2 K2 plus K3 K1 over 8 K2 plus K3. So this is going to cancel and just become over 4. And then this is plus... In order for this to have a 4, I have to do 2 over 2. So this is plus 2 K2 K3 over 4 K2 plus K3. So it's equal to, again, don't forget this part. This is the simplification I made when I did this, because I just don't want to write all the terms. So that's going to be epsilon naught A over D times, right, K1, K2 plus K1, K3 plus 2 K2, K3 all over 4 times K2 plus K3. I think so. I think that's how you do it. It's pretty shitty. Hurts my brain. Do we know the correct answer, Critical? Is this okay?
What's answer, SpongeBob.
Yeah, do we think this is right? I don't know the correct answer yet. Here, let's ask ChatGPT. I'm just curious. See if you can do it. Solve this. Oh, wait, not that. Let it rip. Oh, we have numbers for things. Oh, damn. It's so funny. So ChatGPT is making a mistake. It thinks they're all in parallel. See how it says it makes a mistake here. It says C1, C2, and C3 are all in parallel. I don't think that's true. It's on Chegg. What? Sign in. Yeah, see? They do the same thing. They do K1, and then they do K2 and K3 in parallel. Uh-huh, cool. Yeah, okay. Same answer. Okay, yeah, they do it the same way. So, yeah, the way we have it is correct. I guess I didn't realize that we actually do have numbers for all this. We do have numbers for what the Ks are and the areas and the distances. So, I could have gotten numbers and then just done that. It just would have been a lot of calculator stuff. I think this is cooler to do it like analytically, because when you get to higher level classes in physics, they're not going to give you calculators. You have to figure out how to do this kind of, we say like analytically or like with variables. But anyways. Okay, cool. Good job.
Well done! Well done!
Yes, it's I tagged you in the it's in the chat. It's in the office hours chat there. You're very welcome, dude. All right, let's see. I got Taco Cat and Equity. Well, Taco Cat? Where's Taco?
No.
No. No. Wait, I want to see this one pops up. No, it's not that one. One sec. Yes.
Hello there.
Hello there.
General Kenobi! I put that just for you, dude. All right. Okay, if not, Equity?
Two Scotsmen pretending to be Englishmen. That's quite funny.
All right, let's see what's going on with Penn Center. I want to check out how his thing's going. RFK speaking.
I want to end this surveillance and censorship. I want to protect the Constitution.
I
don't know how this guy
need to
can
eat my
speak.
greens, I need to eat my reds. Hey, that's fair. I know a lot of people that just eat meat. That's it. That's all they do. They don't need
I
greens.
want to end the surveillance.
I like leafy greens,
I
but
wanna end the
that's just a
weaponization
personal
of
opinion.
government
Hey,
against
Poin.
American
How you
politicians.
doing? Do you have elections in Canada? Yeah, we do. Our next election is
And
next
I want
year,
to
I
end the
believe.
chronic disease epidemic.
Again,
Now,
is he going to say anything?
don't you think that we deserve a president in this country who's going to
Okay, so this is a very vacuous statement. I want to end this, but it's like, what's your plan to end? Like, what are we gonna do? What's the point? What are we gonna do?
Can't really hear what he's saying, anyways. Honestly. There you go, Taco Cat. All right, here. All right, Taco Cat.
Or the moral authority of the United.
All right, let's do this, Taco. All right, what's up? You want to learn about astronomical units? These are cool. AU. You know AU is the chemistry sign for gold? We love that. Yeah. AU is very cool. AU. Sorry, I was eating. Oh, it's all good. What were you eating? I need to eat, man. I'm starving. I have not eaten a bit. Okay. Says astronomical unit is the average distance between the Earth and the Sun. So that's kind of cool. So we measure things in terms of, like, you know, how many Earth-Sun distances is it? You know? Another one that comes up a lot, actually Equity had this in one of his questions he was asking, is football fields. Right? If anyone ever says, oh, that building is 5 football fields tall, it's a way of, like, referencing a distance in terms of something that you can kind of picture in your head. Might as well use light years. Yeah, but light years is hard. People don't know how to, like, even fathom how far a light year is. A light year is the distance light travels in a year. Yeah, so, but Earth Sun kind of makes sense. You can think about, oh, how far away are we from the sun, you know? Okay. Because these are really big numbers. So, and it's approximately 1.5 times 10 to the 8th kilometers. Wow. That is, what is that? Is that 150 million kilometers? Yeah, that's a lot of distance. Damn. Okay. The speed of light is around 3.8 times 10 to the 8th. So that's c, which is equal to 3 times 10 to the 8th. So they say the speed of light in astronomical units per minute is... Ooh, I kind of like that. Very good, Taco Cat. Yeah, that makes sense. Yeah, so, yeah, the reason you use AU is because those distances, like from us to the sun, make sense within our solar system. But then when you start looking at how far away things are from our solar system, it gets really, really, really big. And that's why you need to use light years, because otherwise it's just silly. I'm sure I've seen videos, right, as we like zoom out or something, you know, from what's up, Equity? I'll do a question next. This one's easy. If you know how long it takes sunlight to reach the Earth, yeah, it kind of is. Okay. So let's do this. So they're saying what is okay, the speed of light in AU. Okay, so I want to say how many AUs per minute is equal to the speed of light, which is 3 times 10 to the 8th meters in 1 second. Okay? Do you know how to solve this one, Taco Cat? This is a very cool question to solve, and it used something called stoichiometry. We use stoichiometry all the time in chemistry, and you will use it in units conversion here all the time. It's pretty cool. Yeah? So what I need to do is I need to convert both of these units. I need to go from seconds to minutes, but I also need to go from meters to AUs. Well, I'm going to show you how you use it. It's very easy. Okay. All you have to do is come up with, like, conversion factors. Conversion factors are, like, things that are equal. So, for instance, we should know that 1,000 meters is equal to 1 kilometer. Okay? This is an important thing to know. We should also know, right, how many seconds are in a minute? $60. Yeah, okay, good. So 60 seconds are equal to 1 minute. All right. So how I always set this up. So I always say, this is what I want. And this is what I have. And like anything in life, I'm trying to go from what I have to what I want. So the way to do that are to use conversion factors. Okay, multiply by what are called conversion factors. This sounds like budgeting to me. Yeah. Well, yeah. It's, yeah. What I want, what I have. Yeah, kind of. I mean, if you're really poor at budgeting, you can just have everything you want. You just may not have a retirement plan. Not the best. Okay. So. Want and hoof? Yeah, I guess that works too. Let's wait for Joker to blow up this question real quick. We're almost done with it. He's like, oh, where's my explosion? Where's my explosion? I guess pretty funny. Okay, your lowercase a's are awesome. Oh, thank you. Oh, that's actually that's horrendous. Okay. I can write these as fractions, Taco Cat. I can write this as 1,000 meters over 1 kilometer. Or 1 kilometer over 1,000 meters. Okay? Same thing with this. I can write this as 60 seconds over 1 minute. Or 1 minute over 60 seconds. In either case, all of these things are equal to 1. Because this is the same as this. You know if like you divide 3 by 3, if you divide a number by the same number, you get 1? It's the same thing here. 60 seconds is the same as a minute, so it's just equal to 1. So when I multiply these things by conversion factors, I'm not changing the number. I'm not changing what the value of it is, but I'm changing the form of it. Okay? So the first thing I'm going to do is I'm going to want to go from seconds to minutes. Should I multiply it by this one or this one? The left one or the right one? You can take a guess which one you think it is. The right one. Okay, so let's try that. So if I take the right one, take the right one here, and I put it over, okay? There becomes kind of an issue here, right? So when I multiply these things, do you see how I get seconds on the bottom again? This will get me like seconds squared. I don't really want seconds squared on the bottom, right? I want minutes on the bottom. Yeah, okay. So what you want to do is you want to multiply by this thing, okay? Because watch what happens here, Taco. Do you see how seconds will cancel with seconds? And then you're just left with minutes on the bottom? Yeah. So now we've successfully converted our rate from meters per second to at least meters per minute. So we're getting closer. Yeah, all right, cool. Okay. Now we need to go from meters to AU. So this is where it helps sometimes to write out what all the conversions are. So I know 1,000 meters is 1 kilometer. And then I know that 1.5 times 10 to the 8th kilometers is equal to 1 AU. So how can I construct conversion factors out of these things to then multiply by this to get me to AU? Let's remember that we're starting at meters, okay? Might be a little tricky. Okay. So, yeah, Taco, we need to go from meters to kilometers, and then from kilometers to AU. And we're starting so far with meters, right? So let's pick. We want to pick one of these things. 10 to the 11? Where's 10 to the 11 coming from? So look, I have meters here. I want to get it to kilometers. The way to do that would be to pick this one, Taco. Oh, take the 3 from 1,000, add to the 10 to the 8th. Oh, I see. Yeah, I mean, that is correct. Yeah, that's one way to do it. And here, but let's show how to do it with conversion factors. So I can take this thing right here. Taco, right? Let's just take this. Let's pull it down. Okay. And now what that's going to do is the meters from here is going to cancel with the meters from here. So now we've gotten from meters per second to kilometers per minute. Okay, so we're close. We want AUs per minute. So that means we need to use one last conversion factor, which is between kilometers and AU. So I can either say 1.5 times 10 to the 8th kilometers over 1 AU, or 1 AU over 1.8 times 10 to the 8th kilometers. Okay? Which one of these am I going to use? We're trying to get to eventually AUs. And so far, we have kilometers. Good. We used the right one. Yes. Yes. Good job, Taco Cat. Yeah, see, I use this one because now kilometers cancels with kilometers, and our final thing we're left with is AUs per minute. You see that? Yeah, this is really, really, really useful to know, okay? So now what I do is I multiply everything on the top, okay? So we're going to go through, and we're going to multiply everything on the top to get us a number up here. And then we're going to multiply everything on the bottom to get a number down here, and then we're going to divide the two. So I'm going to do 3 times 10 to the 8th, which is the same as 3e8. That little e there, that's 10. Wait, here, let me show you in the calculator. That's times 10 to the 8th. So here, let's clear it. 3 second e8. That's the same thing as 3 times 10 to the 8th. You can watch it this way. Watch, 3 times 10 to the 8th. It's another way to write it. This is called like scientific notation or engineering notation, I think maybe. Yeah, okay. So 3e8 times the 60 times 1 times 1. Good. Okay, cool. And then let's do the bottom, right? Which is 1 times 1 times 1,000 times 1.5 e to the 8, right? That's that. So then we do the top number divided by the bottom number. So we had 1.8 times 10 to the 10th. 1.5 times 10 to the 11th. And that gives me 0.12. Okay? So the speed of light in astronomical units is 0.12 AU per minute. Okay, remember, this was AU per minute, right? Because that's the last thing was left here on the top. That's the last thing left on the bottom. Everything else got canceled out. Okay? And that is going to be choice B. Nice. Good job, Taco Cat.
Hello.
What's up, Ethan?
I can't. You know, I gotta say something. I come in here with good news.
Good news? What's the good news, dude? What's the good news? Tell us the good news.
So you remember how you saw in my report card that I have a C plus in physics right now, or a
I did.
79?
I saw you had a C plus in physics. We want to help you out with that, man. You should have a B at least. You're a smart kid.
Well, hey, I don't mind showing my camera for something.
Okay, show it to me.
Okay, let me just see. See, look at this.
Ooh, it's coming up. Coming up. See what you got. Wow, 20 out of 20. Nice, dude. Hell yeah,
see?
dude. Yeah, good job. That was on a waves.
That
That
was-
was on a waves
That was a
question.
quiz. Yeah, that was based on waves.
Dope, man. Well, that'll help
I
your
mean,
grade
hey.
out. Yeah.
Yeah, it will, most definitely. I've been failing like the past quizzes, so this will definitely put it up to a B at least, or an 80
Nice.
overall.
Oh, I'm glad. I'm proud of you, dude. That's awesome, dude.
Yes, and I got a physics test, I think, on Thursday. And
Okay.
there was one other quiz I took that I haven't gotten that back yet.
Do you have any questions on it? I'm gonna help Equity out with his question, but if you have any physics questions, I'll stick around to do yours.
Well, there is technicality. I don't know how to word it, but it's like, with gas laws.
Yeah, PVNRT.
Well, I wasn't just talking about those. I was talking about three other ones: Charles' law, Boyle's law, and the pressure law. I was talking about those.
Okay.
Apparently, they invented something called a combined gas law, which I might want help in scenarios. Then I don't know how to get a scenario. Like, could you help? Could you like give me a scenario and then we could try solving it together?
Yeah, we could. Yeah. Let me help out Equity real quick, and then we'll do your question. Is that cool?
Sure. I'll just turn my camera off now.
All right, you're good. All right, cool. All right, what's up, Equity? You want to do your question? Oops, put this all off. Go away, Olive. Oh, is that what it's called? Yo, what's going on, dude? Okay, cool. All right. So it says a football player begins running from the 0-yard line of the football field. His starting position and velocity are shown by the yellow dot. His coach starts a stopwatch when he begins running. The player runs across the field with a constant velocity of 6 yards per second. Okay. He's talking about your hair. Gold, can you roll your R like that? Like R. Or arriba.
I never really he was talking about the hair, but thank you for that though.
Yeah, he likes the haircut. Yeah, nice. Okay.
¿Por qué?
¿Por qué? ¿Por qué? Okay. So the
Did you hear what I
equation.
said?
Yes, I did. Yeah, I heard. Yeah, the haircut. I heard.
I was sensation. It was sensation I was talking to.
Oh, sensation. Oh, I didn't hear that.
Oh, no, we didn't hear what you said. What did you say?
Oh, I just said that Taco Cat was complimenting on my hair when he called it a buzz. I was wondering what that meant, but thank you for that comment there.
Oh, buzz means it's shaved down. Yeah, it means it's
Yeah.
Yes.
yeah.
Yes, it definitely stayed down for sure. Yes.
I wonder, is it called a buzz cut because the thing goes like bzzz, like over your head? Is that what they call a buzz cut?
Perhaps.
Perhaps.
Also, quick news. Quick news. I just heard from today.
What's up? Quick news.
Yes. So I was sick for the last week. I've been taking tests, and I heard that I'm gonna get some of them tomorrow, and I'm a little worried then because they kind of looked easy, but I do not think that they would be that easy to the point where I'll get an ID. I can't trust tests these days, you know.
Yeah.
And
Well,
it's just that
you can only trust as well as you did. And then
I'll find out my grades tomorrow. So hopefully I got an A or an A plus on both tests or all
yeah.
the tests then.
Well, let us know. Let us know how you're doing.
Because yes, I'll let you know. DMs maybe?
Yeah.
All right then.
Okay. All right.
Also,
Yeah, what's up?
Buzzcut, without looking it up,
Yeah.
for some strange reason, a lot of Japanese words were made it into the American English lexicon. Now, buzzcut to me sounds like bozukato.
Buzukuta.
So bozu is like well, it's where you shave your head with a wet shaver, but I guess it
Okay.
could be misinterpreted as buzz. So I don't know.
Oh, yeah, maybe it did make it that way. Yeah. I think it's just because they make a buzzing noise, but who knows? Okay, Equity. Distance is velocity times time. This is a standard thing in physics that we want to know. And this is in the absence of acceleration. So this means as long as his speed is not changing. So since we say that the velocity is constant, that means that the acceleration is equal to 0. Okay? So it means his speed is not changing. We can use this simple equation. If not, we'd have to use something a little bit more complicated, which is this. X equals x naught plus v naught t plus 1/2 at squared. This says that position final is position initial times initial velocity times the time times 1/2 the acceleration times the time squared. But because this is happening at constant velocity, this whole thing goes away. And you're just left with this. And since his initial position, right, he starts at 0, right? Since he starts here at 0, this also goes away. So now we're just left with this. Position, which is kind of like distance. They're technically different. Is velocity times the time. So knowing that equity, how could you figure out what his position is at all these different time points? What would you have to do? Still streaming. Six T. Yeah, nice, dude. Yeah, so this is easy. Or 6 times S. Well, 6 times T. So, yeah, here's what you do. You end up doing the velocity, right? Which is 6 yards per second times the time, which is in seconds. And notice how seconds will cancel. So you're just left with yards. So, yeah, you just take this number and you plug it in for T. So that gets you 12, 24, and 36. Pretty simple. Yeah? I'll give you a harder question next time. Yeah. Yeah, good job on this so far. It's a good, like, intro to mechanics. But let me teach you, like, harder physics next time. Yeah. But I'm glad you got this right at least.
Well done. Well done.
Okay. Just because, like, I'm getting hungry. I haven't eaten in so long. I need to eat. Yeah, you're welcome, Equity. Yeah, nice job on getting, yeah, I'm so glad that the what was it? The keyboard you won made it to you. That's really dope. Yeah, look at this. This is what happens when, like, one of my prizes that the kids win goes all the way to Canada. And wait, this gift has been a couple places, right? Didn't I try to ship it to someone in Texas first, and then that didn't work? And then I shipped it to someone in I want to say Virginia or something. I shipped it to, like, a completely different state. Yeah. So this keyboard has been around the United States at this point. And it somehow finally made it to Canada. Yeah. Let's see if it loads. Come on, picture upload. Upload picture. Are you using it right now, Equity? Like, is the keyboard sick? I don't know. It looked cool. I know people pay extra for, like, the all white stuff these days. You know, like, oh, I have to have the white graphics card, or the, you know, it's for, like, a clean white. You haven't opened it yet? Oh, why not? It's a nice keyboard. However, it's pretty pricey. Yeah, people love these. Just like this, like, super frost white setup or something. But you pay a stupid amount of money for the white components. But anyways, yeah, look at this. Look at this. Wow. It's real. It's real. Look, this keyboard made it to Equity and the sign. And Ethan, do you still have the letters that you've gotten, right, from me sending you prizes? Yeah. Yeah, to be fair, it looks really good. Yeah. Sick. I'm glad. I mean, you deserve it, dude. You worked really hard. We are going to start a Winter Games competition. I will do it. But I think I may limit it to just cash prizes, just to make everyone happy. Because as much as you guys love the physical stuff, I understand it's such a pain to, like, ship things to people. So I might just make them as gift cards. Anyways. Oh, Andrew had 100 bond coins. Oh, I need to update the shop, too. Yeah. People said they wanted merch. They wanted some of the math merch I'm making. What happened to the PS5? I still have it. I just haven't given it away to anybody yet. I don't know. Might use it as another prize. Okay, what's up, Ethan?
Yeah. What are you trying to ask here?
Oh, I was seeing if do you have any of the letters that I sent you with the prizes you won? Do you still have these letters?
I don't think so. No.
Oh,
I think there's somewhere deep within my that I can't find
it's
anymore.
okay. Well, it's fine. You got them at some point. All right.
Yeah,
You
I
want to
did.
you
Go
want to
ahead.
do it? You want to do what is it? A combined gas law question?
Yeah, but my one is a little different. It's not the PV is equal to NRT. It's
What is
the
it?
other one.
PV equals
It's
NKT?
P1 V1. What? No, I didn't even
Oh,
get to finish what I was just saying.
okay.
I said I'm saying
What is it?
P1 V1 over T1 is equal to P2 V2 over T2.
Yeah,
That's the
okay.
one that we are given.
So let me show you like where this comes from, Ethan, because it's the same thing. Okay.
Yeah, they're just basically constant. It's like they're all like directly proportional, right? Or is that the right word to use?
P1V1 equals NRT1, right? This is PV equals NRT. And also P2V2 equals NRT2, right? So if I rearrange
Why isn't
these,
the N and the R two as well?
because R is a constant, that does not change. N is the number of moles, okay?
Yeah. Okay. Wait, I thought it
Which,
was R. I thought it was
no,
R that was the
no,
number
no,
of moles.
no, N is the number of moles. And you assume N stays the same unless gas is leaking. Unless there's gas leaking in and out, then you assume it's the same. Okay, but if you divide both sides here, right, you just get equals 1, which is the same thing as saying this whole thing here, right, is equal.
It's the same as that.
Exactly. Yeah, Ethan, yeah. Equals the same thing, right? So since
But yes,
the ends are the same, right, N cancels, R cancels, and now you get down to this equation, which is what you have.
All right. Oh yes, that helps with the origin on how it was originally formatted. But now
Okay.
it's like getting into scenarios. Because in all honesty, there was that one question I asked for you that was coming on a quiz. When I did that exact same format, I didn't fully get the points. I don't know how. I screwed up.
Okay.
All right, even though I remembered everything. So I would like want to I would like for you to give me a scenario so that so that you can train me for this test because I don't want to screw up like that quiz and then
That's not screw up, dude.
the quizzes are like, how do I say it? One thing I've learned about myself then, how did you get that? Without me even seeing where you, how did you get that?
I just did a question. There you go.
You just popped it out of thin air.
Yeah, I did. Well, I just Googled it. I can find questions.
All right then. Well, yes, like I was saying, one thing that I've learned about myself recently is that I kind of have this ability to adapt to any environment, except for like the
Good.
first time. It's like I've realized that with I've realized that most first tests and quizzes I take are like test runs. I'm basically saying that it's for me to interpret or understand what am I going to be dealing with for a while. Then
Uh-huh.
that's what I'm just saying. That quiz was kind of like the test run there, and the real test will be coming soon. So I would like to not mess up this time.
Okay, let's do it. All right, so let's try to do this. It says a gas initially has a pressure of 200 torrs and a volume of 300 milliliters and a temperature of 26 C. The volume is decreased to 0.25 liters and the pressure is increased to 0.60 atmospheres. What will be the final temperature?
Hold on, can I get my calculator for this?
Yeah, let's do it.
All right, I'm back. Got it.
Okay. So I'm just writing down what we know, right? So we know for the first situation, right? P1 is 200 torr, V1 is 300 milliliters, and then T1 is 26 degrees centigrade. Okay. V2, P2 is 0.6 atmospheres. V2 is 0.25 liters, and then we're asked to figure out what T2 is.
All right.
Okay.
I got it.
So before I can use this equation here, Ethan, okay, there's something we got to do with the numbers they gave us, right? What do we got to do with all these numbers?
You gotta convert them into some specific thing.
They need to be the same units, okay? this pressure's in torr and this
Yes.
pressure's in atmospheres. Can't happen. No. Gotta be in the same units.
You need to have. Yeah. Which one are you even gonna convert to from this? I don't even know. Like I've learned about pressure with atmospheric pressure,
Mhm.
kilopascals, pascals, atmosphere, like torque. I
Good.
don't know which one are you converting to? Or like, are you converting to pounds per square inches?
So, no, so for this one, it doesn't really matter which one you convert to as long as they're the same, okay? So I could convert this into atmospheres or I can convert this into torr. It doesn't matter.
And how do you do so? Because I don't see any trend at all.
760 torr is equal to
Oh
1
gosh, not
atmosphere.
that again.
This is something you should know, yeah. And then the other one you want to know
Well,
is that 1,000 milliliters is equal to 1 liter.
hey.
Okay. So which one do you want to convert?
I think it's best to convert to Tor for this. Like,
Okay. I like that.
I think, yeah, that's better than an atmospheric. I don't like dealing with decimals. I don't want to convert decimals at all.
Okay, that's fine. Okay, so you want to convert this one into torr? How do I do that?
Yeah, that's where the problem is. It's like,
Okay.
I
I know
don't
you
know
forget
how to
which
do
one.
it.
Which one? Okay, so this actually goes. Were you watching when I taught Taco Cat? Were you watching him on the last question? It's okay if you weren't.
What? What are you talking about?
When I taught Taco Cat, this question. Oh, you maybe you weren't here when I did this one. Oh, I don't think you were here.
No, well, I joined in late, so I
Okay.
didn't fully see what happened.
Okay. Here's what you're going to do. You're going to write these as fractions. There are a couple ways to write this. You could say 1 ATM over 760 torr, or 760 torr over 1 ATM. Okay? And then this, I'm going to write as 1 liter over 1,000 milliliters, or 1,000 milliliters over 1 liter. Okay?
All right.
Here's what I'm going to do. I'm going to say, question mark, how many, right? We want to know how many torr is equal to 0.6 atmospheres. Okay? And then I want to multiply this by one of these things, one of these conversion factors, to get me back to just torr. Which one do you think I'm going to multiply by, Ethan? The left one or the right one?
760? The right one? The right one?
The right one, good. The reason why I
Why
do the
not
right one, the reason why I do the right one is because atmospheres on the top will cancel with atmospheres on the bottom.
Oh, all right.
Right? If I did this one, I'd have atmospheres both on the top, which is wrong.
No.
Okay?
Because in all honesty, you could just like try to play around with the numbers a little bit to try and get that exact same formats.
You could, but I like to
But-
do this because students always forget whether they're
Sure.
supposed to divide or multiply.
All right.
Jeff said LA called for Trump. Louisiana. Sorry, I read that as Los Angeles. I was like, excuse me. Trump a 75% chance? Wait, I thought there were no upsets yet. How did he have a 75% chance if there are no upsets?
Didn't I say 68%?
Well, Jeff's just said it's 75.
So it's. See, I said 68. You said it had gone way down. And I said, all right, fair. It probably will do. And now he's saying 75%.
I don't know what's going on. I don't know what's going on anymore. The world is crazy.
Well, he'll win. There's no two ways about it. And then Poliviero
no,
will win in Canada.
the Democrats are going to steal it.
I really
Okay.
hope that's not true because it'll be war.
It will be war. Yeah, okay. Anyways, so Ethan, I'm going to do 0.6 times 760, and that gets me 456. Cool?
All right.
Like if I multiply
So-
these two things. So this is the same thing as
So you get-
456 torr.
All right. I feel like there was a simpler way to divide to find that out.
I mean, you could have just multiplied it by 760, but that's exactly what we did. But I want you to get kind of used to doing this so that you don't make the mistake of accidentally dividing when you should be multiplying.
All right, then. Got it.
Okay?
Yep, got
Okay.
it.
So, all right, let's do the next
And
one.
now-
What's the next conversion we have to
The
do?
next- There's another conversion there. milliliters to liters.
Milliliters
Again,
to
I
liters.
think you could just. I think it's better to do milliliters.
Okay, that's fine. So let's see
And
how we
so
would
I
do
think
this.
you just do. So it's like taking the what kind of milliliters is gonna equal to 0.25 liters, right?
Good. How many milliliters equals 0.25
So then-
liters? Yeah.
So you go again for the right one over there, 1,000 milliliters over 1 liter. Right? Since they
I agree.
no
Yeah, no. You
Wait,
you
what?
should do this one. Yeah, this one.
wait, hold on. I just realized they're oh right, they cancel out. I
They
thought I
cancel
mixed it up.
out. Yeah, there you go. Okay.
I thought that I mixed it up there.
So 0.25 times 1,000. So this is cool. Times
It's
1,000 just means move the
0.25.
decimal 3 places. It's 250. Watch. 0.25 equals 1, 2, 3. So it's 250.
Yep, got it.
Good. All right.
All right.
Now there's one little tricky thing here, man.
Oh yes,
And
yes. Converting from Celsius to Kelvin. Yes, I know how
Yeah,
to do this.
degrees centigrade. Yeah, we got to convert this to Kelvin. Do you remember how to do this?
Yeah, if I can truly remember how this goes, the one thing I keep in my head is like K is equal to C plus 273.15, right?
Yeah, good.
So yes, you just do 26 plus 273.15, which in all honesty is just 299.15.
Yeah, good job. Nice. Yeah. Cosmic
I
is
know how to
trivia
do
one here.
Kelvin to Celsius.
Okay, good. You don't know how to do Kelvin to Celsius?
I mean,
You
I
just-
said I
you-
know how to do it.
Oh, okay. Okay,
What?
cool. Yeah, you're good. You're good. Okay, so now that we have
Just,
this, Ethan, what do we do next?
Now you can substitute your values in since now they're kind of the same.
Mm-hmm. So what do you do?
So yeah, P1 is already 200 or whatever that
Mhm.
is, times the V1, which is 300,
Good.
all over 299.15.
Okay, good.
And then for the next one is P2, which is 456 Tor
Mm-hmm.
times 250.
Yep.
And you still do not know what T2 is, so you just leave that undefined.
Good.
And now you can just solve for what can be solved, which is like
Mhm.
200 times 300 over 299.15, which just gives you 200.56. I have 200 and
Let me do it. Sorry. Yeah. My
yeah,
brain
see,
is running out of
200
fuel.
200.
200.57.
200. Well, okay then.
I rounded
And then
the 568 to 57.
Nice.
okay,
Thanks for the
and
follow,
then
dude.
you do 456. You then do 456 times 250, which
Tell me
is
what's that?
114,000 or something. Wait, no, hold on. I don't know how to say that.
How do you say it?
All over T2. 114,000. That's
Good.
what I meant to say.
114,000. Good. Over T2. All right. Now, students always get confused here. You got to be careful.
No,
How do I solve-
I think I know what to do here.
How do you solve
I
for
think I know what to
T2?
do here.
What do you do? What do you do? Show me.
First of all, you just gotta since it's a denominator, you just gotta put it in the numerator side. So multiply T2 on both sides. It's just that simple.
Good. I like that. Yeah. Multiply T2 on both sides. Good. I like that. Some students would like
So now-
multiply by this, and I'm like, no, that's wrong. No.
What?
But yeah, I know it's silly. Okay, so you have T2 times 200.57 equals 114,000. What do we do next?
And then you just divide 200.57 on both sides.
Good.
And then you get that your final answer is like T2 is equal to 56.84 Kelvin.
50.
Wait, what? I think I did something wrong.
I got
Yeah, I did it.
568.
I did it
568.
wrong. I missed a zero.
Okay, that's okay.
Actually, it's 568.39
Kelvin.
Kelvin.
But that's kind of a weird number. How do I put that into centigrade?
Why would you want to put it to Celsius? Temperature must be converted into
I
Kelvin.
don't know because like Kelvin's weird.
How is Kelvin weird? It seems more accurate than a Celsius.
I know, but I
You
can't.
see the-
I can't picture 568 Kelvin. So like, how can I convert this into centigrade?
It's a Celsius. It's just
Yeah.
like taking the formula C is equal to K minus 275,
Good.
272.15.
K minus 273. Good. Yeah, Fahrenheit is the only true scale. Yeah. If the
Which is
presidential
fast-
election keeps going how it is, we will never be able to use centigrade forever. Okay. So good.
Which-
So that gets
you
you
think?
295. Good.
4.4.
Degrees centigrade. Nice.
Optical word in Celsius at the end.
Oh my god, dude.
Have to go.
Yeah, if you're gonna put degrees Celsius, you have to do that. Yeah. Nice. Good job.
Why? Why don't that makes no sense? They say in the notes that temperature must be converted to Kelvin.
Yeah. No, I'm saying your answer that you give the teacher should definitely be in Kelvin, but as an exercise for us, I just wanted you to put it in centigrade. I just want to make sure you could do it.
All right then.
Cool. Nice.
Got it.
Okay. Cool. I don't think we have any more questions for today. Any more screenshots? No. No more. What's up, Cosmic? Cosmic typing something. Has Zach started streaming yet? Dr. Gold is setting you up for success. I'm trying to. Somebody's got to do it.
Have to go. You know, actually, I got this funny little thing I want to tell you.
What do you want to tell me, dude? Tell me, man.
So you know how in like I don't know if it's true or not, but apparently I've heard that when students are going to college and university, apparently there's more people that's cheating right now.
Yes. Yeah,
Is
a
that
lot of
true?
people. Yeah, a lot of people are cheating these days. It's kind of
So
unfortunate.
the thing is that this teacher is making it so hard for every one of us to the point where people are starting to cheat in their tests.
I had something similar happen to me in high school. My history teacher was just being an absolute dick with like how he wrote his exams. So me and a couple friends found out that because he wasn't teaching, and then he would give tests that were nothing like what he taught, and then everyone would fail. And then we figured out that he was using a test bank that you could buy like a CD off of eBay from, and he was just verbatim copy pasting those. So me and a couple friends bought it, and we just started acing all the tests. Eventually, some people got mad at us, and we got in trouble.
Hey.
But in reality, who really got in trouble was the teacher, because the teacher was being lazy and using a publicly available test bank to write shitty tests that didn't have anything to do with what was being taught in class. Exactly. So I understand. I understand from personal experience that if things start getting so bad, you will look for a way to still succeed. And unfortunately, sometimes that means that you end up literally cheating to do it.
But yes, considering on, if you don't mind.
Yeah, go on.
So yes, the thing is, it's like people are cheating on their tests, but I've seen that when they cheat, sometimes they don't get a higher grade than me. Then they copy the words, they copy the notes word for word, but they still don't get it correct, even though the teacher doesn't see them. You know, I just heard my average for physics is still at the 79, but someone else has a 77, and they have been cheating, and they haven't been caught.
Yeah, I mean, you know this, Ethan, right? From the steps challenge, like some kids try to cheat by like doing screenshots of things. If you cheat, you're just cheating yourself, because eventually you still have to know the material, right? If you yeah, make sure you can at least do it. If you end up cheating on tests, or the perfect one this always happens with, Ethan, is cheating on homework. So a lot of kids will just go to Chegg or ChatGPT and they'll just have it do their homework and like, cool, yeah, it's done. But then they end up getting screwed when they try to take the test because they don't actually know the material. So it's unfortunate that people are cheating in your class, but just know that they're only really cheating themselves because eventually it's going to catch up with them. And then they're, you know, not going to be in a good place.
Yes, well, look, I haven't cheated in physics at all, so I'm completely surprised how
I'm so
this
glad,
person
dude.
doesn't even have an 18.
I'm so glad you're not cheating, dude. That's great. Wait, Chrissy
you know,
Slipstream. Yeah, go on.
But speaking of cheating, I did kind of cheat one time, you know.
It's
And this one
it
was for
happens.
desperate measures because I wanted to get an A in math. So in the first test, I was dealing with algebraic expressions, and they had this one question where there was like three different algebraic fractions that I had to solve.
Uh-huh.
And the teacher had given that exact same question in the notes before. So I decided to try and attempt one of the sneakiest things in the
Oh, we're
class.
being sneaky with.
Since I was at the back of the since I'm at the back of the class, I decided to pull out the math notebook and turn to the page that that thing was on. I had the answer there. So I quickly wrote it down and put the book in my bag. The teacher didn't even notice.
Oh wow.
I kind of feel guilty for doing that because now I don't think I deserve the A plus, at least an A.
Yeah.
But I desperate times sometimes call for desperate measures, and I had to do it, you know.
Desperate things call from different desperate measures, yeah.
So look, I do regret it, but I'll try my best to not attempt that again, as long as I can fully understand the topic. But just I have cheated once only, and with that, it helped me get that A plus in math.
Okay. As long as you're learning the material, man. Yeah, put in the work, it'll pay off. Trust the process. I agree, Cosmic. Okay.
So look, all I'm waiting for tomorrow is I hope I get my 90s on that test, like I want.
I hope you do well.
Because so far I've been getting the highest in like 2 out of 3 tests out of 11. Like we've gotten 3 tests back so far. I got the highest in 2 of them. And hopefully that trend continues to go on because I want to be number 1 in my class.
Nice. That's good to want to be number 1. That's really cool. Okay.
All right then.
All right, good to
I
see
guess
you.
we're ending off here.
I am. Yep.
Later then.
All right, peace. All right, we close off stream. All right, thank you everyone for coming to Office Hours Actual Education.
That's dope.
Appreciate everyone who came by, asked questions. Everyone in the chat, you're all lovely. Chrissy, if you ever have questions, I'm always here to give advice on, college trajectory and stuff. Happy to try to, help you out a little bit. Our next stream is going to be tomorrow. That'll be at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. Come on by, get help with your math and science. What we're going to do now is we're going to go raid, Zach. Zach's another awesome math friend of ours, and he's streaming. So if you want to keep learning some math, please follow us with the raid on to go see Zach. If you want to have some fun with another one of our math streamer friends, Penn Center is doing an election watch stream. I'll post the link here for you if you just want to hop over to that real quick.
Look at this guy. Like this guy, what is he?
Penn Center is awesome. He's another math friend of ours. So if you want to check, if you're done learning math and you want to go see the chaos, which is the election, which I'm gonna go do, go hang out with Penn Center. I still actually have to teach one more kid calculus in like an hour, but okay. Otherwise, we're gonna go raid Zach and talk to him about some math education stuff. Anyways, all right. Have a wonderful rest of your Tuesday. We will see you tomorrow. And peace out.
Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep.